Hey everyone, welcome to Simulacra. I'm Bryson, and today we're doing a different style of video. We're building in public. So I'm building a decentralized financial application that allows users to interact with Bitcoin, Ethereum, and gold and silver stablecoins. So I've done some researching and ideation, brainstorming sessions to determine what kind of app I really want to make, what should the functional and non-functional requirements be. And so we're going to start building, and I might as well build on YouTube in public with all of you so we can go through the trials and tribulations and wins and losses of building anything that users can actually use. So we're doing the first session today, which is system design. We're going over the non-functional requirements, the functional requirements. We're going to go into the APIs and the core entities of our app that will influence the data flow on our app, and we're going to build the full wireframed out system design of the application. And then we'll go into some deep dives in different parts of the application, basically to see where we can improve in regards to scalability, redundancy, fault tolerance, compliance, making sure our app is secure, and things like that. And we're also going to talk about some tools I'm using as we get deeper into the development. A major tool I'm using being Foundry for smart contract development and testing. Smart contract development and testing is super important, and Foundry is a really good seamless tool for developing your smart contracts. And so we're going to get into system design today. This is the February 12th, 2026. It's about 11 a.m. Eastern Time, session one, building a decentralized financial application. So I hope you enjoy, and let's get into it. Okay, so system design is going to be extremely important, especially in the age of AI, where honestly, being able to code in specific languages is not really going to be as important as much. The ability to think about a system holistically, how it can scale, and how it can handle different consistency or availability strains is extremely important. And so a good framework for developing a application or a feature for an application is having non-functional and functional requirements that need to be satisfied. And then once we have non-functional and functional requirements, we can start actually developing the different aspects, data flow, API of our application. And so let's start up here. We're going to first develop a little framework to help with getting a clearer sense of how to go about thinking about system design. So, up top, we want to have the primary goals, and these are going to the primary goal is to satisfy both of our non-functional and functional requirements. Cool. So, primary goal, we want to satisfy our non-functional requirements, and then we also have a primary goal of satisfying the functional requirements. All right, so you have your non-functional and functional requirements. And basically, a good way to think about these is that the non-functional requirements is what is the system able to do, and the functional requirements is what is the user able to do. And so that's a good way to break up both of these, and you can get a clear picture of exactly what your app is doing and why it's doing it and what requirements is it satisfying. And so we can think about systems design in 6 steps. First will be requirements. These are our functional and non-functional requirements. And then the core entities. The core entities of your application would be things like, if you think about Twitter, the core entities of Twitter are the user, the tweets, the feed. And so the core entities are things that make your app your app. And so we'll go into these a little bit later. And then next, you have your APIs / interface. And your APIs interfaces, how is your application interacting with other applications? How is your application interacting with other applications, and what sorts of GET request and POST request do you need to have in this application? Next is your entire data flow for the app, data flow, high-level design, and then you have your deep dives over on the right. And so we can draw arrows to these different aspects of system design. And so this is a really good framework for understanding how to develop applications. And so as you can see, we have requirements, core entities, API interfaces, the data flow, high-level design, and deep dives. And so if we start over here, we can see that not all of the components are touched on by the functional and non-functional requirements. And so if you go here, we want our requirements to both satisfy our non-functional and functional requirements. And so we will start with our requirements because they're the foundation of our application. Later, when we get into the high-level design and the deep dives, these two will allow us to draw back on our non-functional and functional requirements to develop the wireframe of the app, so that we are good to go by the time we start coding. And so I have functional requirements that I already brainstormed for this application. So we're going to write some of them out now and start getting into the nitty-gritty of the system design. So let's go down here. Let's say functional requirements. So functional requirements. So for this app, we're developing a decentralized finance application that allows users to view the balances of crypto addresses that they post into the app, and also allow users to fund what I'm called community pools, which is just a community fund of different tokens, whether that be Bitcoin, Ethereum, or the stable coins for gold or silver. And so the point is to develop a kind of communal app that allows users to view their balances from across their crypto addresses in one hub, and then also they have the ability to fund smart contracts called community pools. These community pools will hold funds, allow multiple owners to be owners of one community pool, and so on. So we're going to start getting into some functional requirements that I thought about. So first, users should be able to create an account using username, email, address, password, etc. So that is a first requirement. Second, users should be able to see the balance of their BTC, their Ethereum, and their gold / silver stablecoins by posting a crypto address into app. We will also want the users to be able to see that balance in one place. So I have a massive problem as a user right now. I have Bitcoin across different applications and exchanges and cold wallets. And so it would be very convenient for me to be able to post all of my addresses into one application and see my total balance of Bitcoin. Okay. We also want the users to be able to deploy a smart contract. And if you noticed, all of these phrases start with users should be able to. You have to remember when you're developing the functional requirements for your app, you want to be user focused, user centered. So users should be able to deploy a smart contract that allows users to fund the contract with tokens. And those tokens are the tokens that we were talking about earlier. So what else do we want our users to do? Well, we want to make sure that only the owners of those contracts can actually withdraw funds from the contract. We wouldn't want anybody just being able to withdraw those funds. That would defeat the purpose of a secure community pool. So user, or if there are multiple owners of a contract, only users, and in quotes we can put owners, in brackets we can put owners, should be able to withdraw funds from the contract. So these are some of our functional requirements. Remember, when you're really starting to develop the skeleton of the application, you don't need to go crazy. You just need to make sure that you are satisfying the main overarching goals of your application. So now we're going to get into some non-functional requirements. So let's go with non-func requirements. I don't feel like writing all that out, so we're going to just start with that. And so for non-functional requirements, like I said, you want to make sure that you are thinking about what should the system be able to do based on these functional requirements. What should the system be able to do? And so I did some brainstorming earlier, and we're going to break down non-functional requirements into different areas. And you can break down these areas based on the scalability of your app, the latency of your app, what latency concerns do you have, what security concerns do you have, do you have any fault tolerance concerns, or where does your app need redundancy, where does it need to be durable. And so these non-functional requirements might be long and you might think that they're pretty detailed, but they're very important in terms of the underground, the back end function of your application, and overall making sure that your application is very scalable and always consistent or available for your users. Let's start with scalability. We're going to assume that this application is going to have a good start. Why would we not assume it's not going to be a successful application? So we're going to make sure that the application can handle a good amount of daily active users. For scalability / latency, those two things go hand in hand. And let's bring this up so everyone can see. So for scalability and latency, the system should be able to scale to support, let's say, 200,000 daily active users. And let's say that 10% of those users will be concurrent at peak. For added granularity, we can add 1 million requests per second. So already we are thinking about how can this application scale what happens if one day I make a viral piece of content for this application and 150,000, 200,000 people come to the application? What if 10% of those 200,000, come to the application? How are we going to handle those scaling issues? So next, in terms of scalability or latency, I want users to be able to have a lot of optionality in terms of how many crypto addresses they can post, how many watch crypto addresses they can see the balance of. Because, I have a good amount, but everybody is different and some people may have way more than me. So I want to make sure that my users are covered and not capped really prematurely at a number of addresses that they can see the balance of. So the system should be able to, support up to 50 watched addresses per user. And 50 may be a lot, but when you're talking about people who are traders, maybe whales that have a lot of assets in cryptocurrencies or stablecoins, then having 50 different accounts is maybe not that crazy. But I'm giving my users wiggle room, and so they don't get capped. Also, so next, the system should be able to return these balances to the users very quickly. We don't want users waiting 15 seconds for a balance to come back. What if they really need that in a pinch and in a hurry? Then we want to make sure that we're getting this information back to our users. And that's where later we'll talk about more in terms of when you're building applications and cap theorem. Your consistency of your data and your application, or the availability of your data and your application to your users, and certain trade-offs choosing between the two. So we want to make sure that our users are getting these balances from these watch addresses in a decent amount of time. So the system should be able to return balances under, let's say, 3 seconds. 3 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi. I think that's a good enough time. If you post an address, the balance comes back to you in less than 3 seconds. And this is where, when you're building scalability and you're going into your non-functional requirements, you can get very granular in terms of thinking about how users are interacting with your application. And so to help out with scalability, for instance, say a user has already retrieved this balance and they already have it on their account. And so we're going to want that balance, a new fresh balance, not a stale balance. We don't want stale data to be returned when the user comes onto the application. So on a refresh on a page load, or a refresh on a completely new sign in to the account. So for instance, we can say the system should be able to return balances under 3 seconds for a refresh page load. And then we can break that down into, also, system should be able to return balances under 3 seconds on a refresh page load and manual refresh. And so that will handle when a user is already inside of our application and just presses the refresh button. And that will handle when a user signs into our application and they need to get a new non-stale balance for their crypto address. Also, in terms of scalability, this is where you can think about things like security. And it's very interesting that different aspects of the non-functional requirements will start to influence other aspects. But this is where you can think about things like how your security affects your scalability of the application. We want to make sure that users cannot spam the application. If users are spamming the application with requests, that means that our application can be slowed down and bogged down by request, and that could be a major bottleneck. And so we want to make sure that users are not able to just spam manual refreshes for those balances that they want to see for their crypto addresses. And so to handle this potential problem or this potential bottleneck, we want to make sure that the system should be able to, or the system should have, let's say the system should have a per user rate limit on manual refreshes. And we can get even more granular with that. We could say, let's say, I don't know, one refresh per 5 seconds. One refresh per 5 seconds per user. So that makes sure that each user only gets one refresh per 5 seconds. So they're not constantly just spamming our application with requests. That's a big way that our application could be taken down by a distributed denial of service attack or some other injection attack. So that handles a good amount of scalability and latency for the high level aspect of our application. We can definitely get into more detail when it comes to where we can also cut latency and increase the ability for a scalable system. But I think this is a good starting point for right now. So next, we're going to start on compliance. I didn't want to think too hard about compliance for a Web3 decentralized finance application, but I wanted to make sure, I think the biggest way outside of making sure databases are secure and things like that, since my application is not directly handling users' funds, it's not a wallet, and it's not an exchange, I don't have to worry about losing people's money. On the application, the funds are executed by a smart contract. They're not executed by my application. You can basically deploy the smart contract from my application, but all of your funds will live in the smart contract, and only the owner has access to the smart contract and can withdraw from that smart contract. So in terms of compliance, I mainly need to worry about anti-money laundering and knowing what kind of user is on my application. Who is my client, basically. And so we can say the system should require users to submit their, let's say, permanent/mailing address after account creation. And we can get granular with that and say at least 4 hours after account creation. So we could say the system should require users to submit their permanent mailing address after account creation. We can also make sure that we have an added layer of compliance for Know Your Client and anti-money laundering policies by saying the system should require users to submit license number with account creation. So when users create an account, they'll be asked to submit their license number, their permanent/mailing address, along with the username, email address, and password. And so that'll give us a comprehensive user profile that will make sure that our application is anti-money laundering and Know Your Client compliant. All right, so cool. Next, let's go into security. How can we think about security of our application? And I think there's two main ways, and we can get into more as we start building the app. But there are two main ways to think about security. We want to make sure that our app is secure from people who aren't even really users of our application. We want to make sure that our application is not getting botted. We want to make sure that actual humans are doing things on our application. Now that gets a little bit harder with the rise of agentic AI and AI being able to answer emails and do things like that. But still adding some layers of security is always very good for your application. And so we're going to start with the system should require users to input a verification. Let's say just verify code, and it will be sent to their email to create an account. So to create an account on the application, you're going to need to input a verification code that will be sent to your email when you create an account /sign in. And so that makes sure that there's just another layer of security to our application for bad actors. So we're going to go with another security measure. And this has to do with the actual transactions that is happening for the community pools. We want to make sure that those transactions are being deployed securely. So let's say the system should execute user transactions securely. And we can get into more granularity about what that exactly means, but we can say that RPC nodes are useful for this. And so RPC nodes are called remote procedure calls. And they're sort of like APIs. And they're basically nodes that are just specialized servers, and they act as the bridge between decentralized applications, wallets, blockchain networks, and other software applications. They're basically like APIs for decentralized applications. And so we can use a tool like Alchemy to handle our blockchain connectivity RPC nodes. So we'll get to this when we are ready to start doing some actual developing and testing for this application. Security, compliance, scalability, fault tolerance. So fault tolerance is a very important thing in your app. Fault tolerance is simply a system's ability to continue operating despite failure from the other aspects or components from your application. We can think about fault tolerance very simply in that we will say that our system should be able to handle failures and retries for functions, contracts, etc. And so we'll see as we are developing the functions for the smart contracts and then the test for those functions that we are going to have to go to Solidity documentation or Rust documentation to make sure that we are handling the failures and the retries. What happens when your function is called and it doesn't do what it's supposed to do? How do you handle that retry? Do you go back and call again? How do you handle the message to your users? Are you going to tell your users that, hey, this function is not able to be done, try again? Or you're going to not send them a notification? So those are some things we will think about as we develop the app a little bit more. And so lastly, but not least, there is a ton of non-functional requirements you can go through, but we're going to end with redundancy and durability. I spelled redundancy wrong. So redundancy and durability. Essentially, where does your app need to perform again and again and again with consistency at the same time so that your users get the same experience? And durability, where does your app need to be durable, especially in terms of data, so that your data is not lost and that users have access to this data with consistency or availability? So let's think of a first one. The system should be able to hold users in a database, let's say DB, for reference when logging in, KYC, know your client, and anti-money laundering. And so we want to make sure that the users that are coming to the application are being logged in a database so that A, we are fulfilling our know your client and anti-money laundering policies, but also so that the users don't have to create a new account every single time that they visit the application, and all of their information associated with their account is tied to their account. Now, all of the metadata and ABI data and other blockchain data will be able to be accessed using the transaction address or the crypto address of the community pool, but you still want users to be able to see what's happening with their features and products in your application. Next, we're going to go with the system should be able to hold user addresses after contract execution. All right, next. So what else needs to be redundant? Well, we want to make sure that when a user executes or deploys or funds a community pool, we want to make sure that those transactions and those addresses for them transactions are held in a database and users can see all of their transactions in one place. So the system should be able to hold user transactions addresses after contract execution. And for more granularity, we can say we want there to be a model or a button, a modal or a button to the block explorer so that the user can see their exact community pool or that exact transaction they just made on the actual blockchain. And then lastly, we want to make sure that the system as a whole complies with our anti-money laundering and our know your client policies. That is spelled, I said compile, but I meant to say comply. And so these will be our non-functional requirements. Not an exhaustive list, but a very good list to start off with to think about how exactly will your app function, what can the users do, and what should the system be able to do that allows your users to continuously use your app the way it's designed. So those are our functional requirements and non-functional requirements. So now that we have our functional requirements and now that we have our non-functional requirements, we need to think about something that is called cap theory. And cap theory is part of your non-functional requirements, but it's also going to be a major overarching theme of your application. And so basically cap theorem says that you have consistency, availability, and partition. And a system should have partition tolerance, which basically means that the system works despite network failures. So if one part of your system fails, but another part of your system is good to go, boom, that one fails. Let's say they're connected, boom. That system can still work even though this system fails. That is what partition is in cap theory. Now, partition tolerance is an absolute must in application system design development. We can't do without, but a major trade-off will be between consistency and availability. Consistency is that the system has consistency, meaning that all the nodes or the users see the same data at the same time. Availability means that all of the nodes or the users will always have available data, even though that data may be stale or out of date. And so as you can see, there's a major trade-off between these two, where you want to make sure that users are receiving data that is always available when they need it, but sometimes that data may be stale because it might not have been updated yet. There might have been a change to a database. Your cache might not have synchronously or asynchronously flushed to your database. There's a myriad of other reasons why your data could be stale. And so you want to make sure that you think about, all right, for this application, what is more important? Is it more important that my users have data all the time, or is it more important that that data is always consistent? And so for this application and thinking about some of these non-functional and functional requirements, I made the decision that this application needs to be more consistent than available. And that doesn't mean that we're going to make sure that the application is not giving the users the exact data that they need to, but I want to prioritize that data being correct and that data being up to date rather than that data being available quickly. For our cap theorem, and we're going to write this down here. So let's move over here. We'll just add it down here because it's a part of the non-functional requirements. Your cap theorem, and I'm going to say I want the partition, which is always needed in cap theorem. The system should have partition tolerance. That means the system works despite network or node failures. As we just talked about, this application needs to be more consistent than available. We still want to make sure that data is available for our users, but we want to make sure that that data is very consistent since we're dealing with user balances and financial data. For our consistency, we want to make sure that the system should have consistency. And that just means that all nodes, users, see same data at same time. So now we have the functional requirements, the non-functional requirements. We've talked about cap theorem, and we have answered the question of should we value consistency or availability more in this app. So now what do we want to do? Well, now we want to start developing the core entities of the application. And again, those core entities are the aspects of your application that your application cannot function without them. So if you're building Twitter, your core entities would be the user, the tweet, the feed that the tweet comes on, and things like that. So let's go into our core entities. What are going to be the core entities of our application? So we'll continue writing under here, core entities, did I spell that correctly? I did. And they are basically, a good way to think about a core entity is a noun or resource necessary to satisfy your functional requirements. So for this decentralized financial application, we're going to have core entities of a user. We're going to have your token balance. We're going to have community pool that people can fund, and that is going to be a smart contract. We're going to have the actual transactions. We want to treat the transactions as a core entity because they hold a lot of data that will be important for our user. And then we want to have the addresses is also a core entity. So the user will post the digital addresses inside of the application, which will give them back a token balance. The user can also deploy community pools, which are smart contracts, and they can deploy them, fund a community pool, and withdraw from a community pool if they are the owner. And all of those community pools and all of those executions of smart contracts will lead to the transactions. So these will be our main core entities of our application. And so from your core entities, remember, if we go all the way back to our system design framework, our core entities are next. We just came from the functional and non-functional requirements. Now it's time to develop the API and the interface. And we don't actually have to develop really super intense code for this. We're really just thinking about what kinds of things is our application posting and what does our application need to get from other applications. Thinking about APIs from a Web3 application aspect, we have to understand that apps requiring blockchain data have client-server models, and that client-server model is the RPC node. So next, we want to write our APIs. So we have to think about what exactly are users doing in our application. Well, first, they're posting addresses. So they're posting addresses to the application and receiving balances. Say v1 addresses, and it's a post request, and the body will be a text, which is a string. And that text will be the address that the user wants to see the balance of. So boom. So that's our first post request. And so now that we're posting these addresses, we have to get and return the balance. So we're going to have our get request. So we have v1, and we can have the balances of those addresses, and we can have that be the ID, address ID, which will be the address balance. So we're getting the address balance by going to the address ID and getting the balance of that address ID. And so what else are we doing? So the users are deploying community pools, which are the smart contracts that users can hold funds in. So that is another post request. And so we're going with version 1, and we're going to call these the contracts. And so our body of this post request will be the actual smart contract. So we can just say the community pool, which is a smart contract, and we can just say this is a smart contract. And saying this is a smart contract, we know that this will be written in a language that is suitable. Next, users can not only post or deploy the community pool, they can also fund it. But funding is another post request because you're writing to the smart contract. So we're gonna have another post request, and this is where we can fund the community pool. And so we have a post request, and our body is going to be the community pool, and that will also be a smart contract. And so we know that this post request is funding this community pool, and that community pool request is a smart contract. All right, cool. So what else can we do? Well, we need another one for withdrawing. So withdrawing is another write function which we are posting to something. And so what can users also do with these community pools? Well, they can also withdraw from the community pool. So that's going to be our post, because withdrawing is also a writing function. So we're going to contracts, we're going to withdraw from the community pool, and we're going to denote that as a smart contract. All right. And so lastly, what else are we doing? Well, users are not only up here getting the balances of an address ID when they post an address ID into the application, they're also getting the information on the community pool that they deployed or funded or withdrew from. So we need to make sure that when a user posts the community pool transaction ID or address ID, they get back pool data, and that pool data could be either metadata for the smart contract, it'd be ABI data, and so we need to account for this request. And we're going to say community pool, and we're going to have pool data. And so in our body, we're going to have this pool data be in a form of a string probably. It's usually ABI data for smart contracts are usually in the form of JSONs. And so under here, we can say ABI metadata for our smart contracts. And so these are some of our APIs that we can think about when developing our application. And so as you can see, the APIs don't have to be super detailed for right now. We're going to actually code out the full API and make sure it's secure, everything like that. But this is a good way to think about and visualize what exactly is your app doing and what is the data flow of your app. And so now that makes it very easy to just write out the data flow of the app based on the core entities here and your API or your interface. Now you can write your data flow. So if we go here, and your data flow can just be in a list. It can just be in a list. And so what do users do on our app? So a user creates an account, and we know we have your KYC, anti-money laundering, etc. So the user creates an account. Second thing that they do is the user can read balances of an posted address or addresses. Third, the user can deploy smart contracts, which are community pools. So fourth, the user can fill those community pools, or they can fund those community pools. Fifth, the user can withdraw community pool. And lastly, a user can see all of the information regarding the transactions for the community pool. So the user can see the recent transactions of a community pool. And this is our data flow of our application. Pretty seamless, pretty easy. And now we can get into actually wireframing and drawing out these different aspects and components of the application based on our data flow, the core entities, the APIs, and the functional and non-functional requirements. And so if I go back and scale out, this is very hard to see now, but this is a very good framework for developing applications and going about developing systems. Starting it with your requirements, going into who is actually affected, what nouns and resources is this application actually doing and using and acting upon, the different requests that my application is going to make to other applications, how data is going to flow, and now we're going to get into high-level design. And in the next video, we'll go into the high-level design and deep dives for the Web3 application. So, if you like this video, please support the channel, like and subscribe, send to your friends. I'm Bryson, and you're watching another video from Simulacra. Bye, everyone. Welcome back to another rendition of Simulacra. I'm Bryson, and today is session 2 of building a decentralized application. So in last session, we went over the requirements, non-functional and functional, the core entities of the app, the API and the interface, and the data flow. And in this session, we will be actually drawing out the application using a wireframe, and then going into some deep dives into where we can actually bolster our application and adhere to our non-functional requirements. So stay tuned for session 2 of building a decentralized application. Today we're doing high-level design. Hope you enjoy. Let's get into it. All right, so welcome to session 2. We left off on data flow the last time, and that was coming off of our full system design architecture, where we have our primary goals, which will be to satisfy our functional and non-functional requirements. Then we have our requirements, core entities, API interface, data flow, high-level design, and deep dives. And so today, we're going to be going into high-level design. Now, when you want to think about high-level design, you want to think about, first of all, drawing the skeleton of your application very simply, and then we'll go into where we can actually scale the application, make more sense of our different functions and services, and so on. So first of all, we want to start with your client or your user. That's going to be your main core entity. And so we just want to take a box and make sure we put client over right here. So your client or your user will always go and hit an API gateway and load balancer before they interact with your application. This bolsters security and then also handles request and rate limits on request. And we'll get into that a little bit later. So cool. So pretty much every application is going to start like this, with a client going to an API gateway and then some sort of load balancer to balance requests that are coming in. So we're going to do this. So we're going to put one right here. All right, cool. So now we need to think about what sorts of things our application actually does. Well, we know that firstly, we know that our application takes address balances or community pool balances and can basically send the user back information regarding the balance of an address or a community pool. And so we need to make sure that we have that service taken care of. So let's come over here, it's right here, and we'll put the service that takes care of our address balances and the community pool info over here. And we know that we have to use a post request because we're posting an address or posting a transaction hash. And so we can make this a post request to our service right here. Cool. So we have that. And so what are some of the things that we want a balance address or an address to have in terms of info for our database that we're going to collect of address balances and any other user requests regarding information for the community pool? So we know that we're going to have for each address an ID, which is just the unique identifier for that address. The actual address ID for the blockchain, the address balance, and then the transaction hash ID for the pool or community pool info. So if our client is requesting this information, then we're going to need a database. And since our database is going to be pretty simple, we can use a Postgres database. Postgres databases are just relational databases. So think of tables, rows, and columns. When you want data that is pretty structured, you can use a Postgres database. But when you have things like maybe blob storage, or so that would be media or videos or audio, you want to use more of a non-relational database. But we're going to use Postgres. Postgres is extremely scalable, so we don't have to worry about any problems with reading heavily to the database. We know that our database is going to be very read heavy, and then our actual service for the address balances and the community pool information is going to be very write heavy. We'll get into how we can optimize that in a second. But so for our database, what kind of information does our database need to have? Well, we want to make sure that it has the same kind of things as our address pool, community pool service has over here. And so let's do that. Let's bring that over here. And we want to make sure that our database for our address balances and community pool information have all of the same tags as down here. We also want to make sure that the database can support up to 50 addresses per user so that our users with, a lot of different accounts for their crypto can be supported. Next, we have the actual service that deploys, funds, and withdraws from the community pool. We'll have that service, and we can put that service down here. And what exactly are we going to do to this service? Well, we're going to fund community pools, deploy community pools, and we can withdraw from community pools. And so all of those functions would be writing. We're writing to change the smart contract on the blockchain. So we know that we are posting a community pool when we want to deploy it. We can fund it also, and we can withdraw also, which are all post requests. So let's put our arrows from our load balancer. And next, we want to think about what kind of data our community pools are having. What happens during the withdrawal, the fund, and the deploy? Well, I wrote down some metadata and other attributes earlier, and so we can just copy and paste it down here. So for each deploy function, there needs to be a pool because we're deploying a community pool. And each pool will have a pool ID, the actual address ID of the community pool smart contract, the transaction hash ID of funding, withdrawing, and deploying the community pool, the pool balance, the available tokens that the pool can accept, any of the owners functions or rights, and then any metadata that has to do with the pool, whether that be the expiration date, fund limits, and the supported tokens, owners, etc. Next, we can say that the fund and the deploy will have the same parameters also. So we can put fund and deploy right here. And so we know that those will have the same parameters because they're doing the same thing, but just the opposite of each other. One, you are funding an account, and one, you're withdrawing from the account. So cool. Next, we need a database for the community pools. We need a database for the community pools. And so, because we already have our database over here, but we need another database for our community pools because it's going to be a lot of information. and we want to keep them separate. Now, you could keep the address balance and the community pools database as one database, but there are problems that we will talk about later, such as stampeding and such, that it might be a good idea for us to keep two separate databases. We can always change later. We want to draw, and let me actually make all of this way smaller. Let's draw our database over on this area over here. So we have our community pools database. We're going to do a Postgres database because we don't have any non-relational data right now, any blob storage. We just have rows and columns. And so our communities pools database are going to have different parameters also. Right here, we can see there's going to be a pool, which is going to have a unique ID, an address ID, that's the actual blockchain address, the transaction hash ID, the pool balance, pool owners, etc. It's the same thing we went over. We want to make sure that our address balance service also has access to this database because our users are also posting the community pool addresses to get information on the community pool. So we want to have our service to have access to both. Now we can see that our service is able to hit our address balance database, and it's able to go to the community pools database to satisfy the user's request for information when they post an address or a transaction hash ID of the community pool or a crypto address. And so this is pretty simple in terms of what we want to do and what our app is going to do. But there are some places that we can now add a little bit more granularity to make sure that we're taking care of all of our non-functional requirements. Over here, we need to make sure that we're following the Know Your Client policies and anti-money laundering policies. And so before our client, we're going to want to make sure that we have a service that allows our client to sign up or log in to our web application. And this is going to be a very write-heavy service because we're creating an account every time, or we're signing in or logging in every time that our client or user comes to our web application. So we're going to put that right here. And so even though that we have a API gateway and a load balancer, we still want to make sure that random users can't just overload our web application with requests. And so we want to have a rate limit to limit the amount of requests that any user can make on an ongoing basis. And then we also want to make sure that the application sends the user back a status code or an error code saying why their request was limited. And that'll be a 429 HTTP status code for too many requests. We can add rate limiters, and let's say that we'll have these additional headers when we add a rate limit. So we'll have a rate limit, and that's just going to be the limit ceiling for that request. It could be one request per 5 seconds. And then our remaining would be just the number of requests left in the current window, how many requests are left that the user can actually make, and then lastly, when that rate limit resets. So when that rate limit resets, you can have a timestamp and then a retry period, which could be 5 seconds. And so this is a great way to make sure that their users are not overloading your application with requests. So what's another way we can add security to our web application? Well, we can require users to input verification by email or number when they are signing in to our application. So this makes sure that we don't have any bots. We have real people with real numbers and emails that are using our application. So good. And then, so we need to make sure to add this 429 too many request status code when a user sends too many requests in too short a period to our application. So now we just handle a little bit of security and front end of knowing who is going onto our application, what their intentions are, and making sure that they cannot do some sort of stampeding or denial of service attack to our application. Now, where else can we bolster this application to make sure that we are handling our non-functional applications? We want to make sure that our users have a database so they're not constantly having to sign up and create accounts. Once they create an account, they have all their information, and so our application just can retrieve their information whenever they are requesting a request. So we're going to have a database for our users. We can put that up here. And this database is going to be a read-heavy database coming from the write-heavy client account creation service. And so we want to make sure that our service for creating an account is going to our database, and that also the client can read directly from the database when needed. So that's right there. We can have a database, and it can also be a Postgres because it's just going to be a relational database of columns and rows and pretty simple tables. But we want to make sure that we are adhering to Know Your Client. And basically, Know Your Client is making sure that each user that is on your application, and this is especially important in financial applications, and especially important in decentralized financial applications where anybody can have a crypto wallet, that we want to make sure that only good actors are on we want to make sure that only good actors are using our web application. No bad actors. And a good way to protect yourself as a developer is making sure that you have important and relevant information on your user. And so some of the parameters that make sure that your web application adheres to Know Your Client policies are having your client's full name, date of birth, physical address, a phone number, and an ID or a license number that can actually be matched to that physical address. Really, the full name, date of birth, physical address, and ID license number are super important in Know Your Client policies that basically make sure that you are interacting with a real person and a real person is using your application. Now that we have that, we've dealt with a lot of security of our app now. We have a rate limit. We require users to input a verification before they come on. We collect all of this information about them when they are creating an account. And then when they send too many requests, we send them a failure status code back. And so from the front end, we have some of the security aspects taken care of. Obviously, we can get way more in depth, but from a high level design, I think this is a good start. And so with our application, what do we need to think of next? Well, we want to have a way where there's not a stampede possibility when users are making requests to our application. A good way to, instead of using databases, a good way to handle stampeding is using caches. And so you can use a memory cache like Redis to basically hold information for a certain period of time, and it allows your application to be way more flexible and scalable so that your request doesn't always have to go to your database. We can go to the cache and check the cache for the information, and if the cache is not in the and if the information is not in the cache, then we can go and check the database to fulfill the user request. And so one of the first places we can add a Redis cache is at this API gateway. We can add a Redis cache here. And this is a way we can help with also handling requests that come in and making sure that our API gateway and load balancers don't get overrun with requests. So any common requests from the client, we can just go and hit the Redis cache, see if we actually already have that request, and then send it back to them. And so a great way to think about caches, or one good way, is to think about bucket sizes and then the rate of tokens in that bucket that are decreasing as time goes on. So we can say that we have a rate of 1 token per 5 seconds, and then the bucket size of the actual Redis cache would be 100 tokens. The way that this flow in this process would go is that a request would come in, the gateway would fetch the token and the last refill time from Redis. We would then have a request, which would be a HM get, and that would be the client. You're getting the client and then the bucket tokens last refill. So next we're updating the counts based on the rate in the last refill. And then we're responding pass or fail based on if the tokens are greater than 0. And then we're updating the bucket status. And so this is another way, other than the rate limit down here, to make sure that our application is not getting overloaded requests. And we have some sort of basically filter to make sure that users can make requests, but these requests aren't leading to the unscalability of our application. And as you can see, this is kind of a problem because that means we're constantly reading and writing to this Redis instance, this cache. But it's not too bad of a problem because we can use things like Redis Lua scripts. And basically, it's just a single instance of Redis, and it allows you to read and write atomic problems. And basically, you read and write, and you see those in one instance, and it takes care of that. So we can put that over here and remind ourselves to use a single Redis Lua script to drum up our Redis instance when we are creating this cache over here. There's another place that we would want to cache, and that is all the way over here with our address balance and our pull info service. Now remember, this is very write heavy, and so the flow of our application is that a client is using a address or transaction hash to get information about some sort of crypto address or community pool. And so we're constantly hitting this database, constantly hitting it, constantly hitting it, constantly hitting it. But there's a problem. What happens if a bunch of users at once want to get a certain address balance and they all hit this database at once? Well, in that case, so since we have this service constantly going to this address balance and wanting information back, we can create a cache to check if the data is present in the cache first or has been recently requested first, and then we can return it to the service, which returns it to the client before we actually even hit the database over here. So let's go up here and let's create another Redis cache down here. So let's go over here. We can create another one. So we want to make sure that our application checks the cache first. And if the data is present, it returns to the address balance or community pool service, which returns the information back to the user. And if not, you have to query the database, and then you restore the result and the time to live and return. And so that ensures that if a user went and requested the balance or some information on a community pool 5 minutes ago, then it would just hit the Redis cache instead of going all the way to the database, which could be more computationally expensive and not efficient in the slightest. We have this cache over here for quick checking for requests. But we also have another problem. So what happens if a bunch of requests come in and we're hitting the Redis cache constantly and we have an overrun cache, which is called a stampede? And so when we have a stampede and the cache fails and the database is overrun, we can proactively refresh the cache keys before the time to live to prevent popular keys from expiring and stampeding. And so we want to make sure that when we're setting up this Redis cache instance, that we make sure to structure it so that we proactively refresh cache keys before that TTL to prevent stampeding and expiring. And so to get a better sense of that, I'm going to go over here and draw out a little wireframe to show you exactly how caching works and how sharding also affects caching. So if we take this, let's post this over here. So right now, this is a pretty simplified version of our web application. You have your client, you have your application server, which hosts requests, you have your cache, and then you have your database. So this pretty simple structure shows our process for our application. And so there's really two main ways to cache. You can have our cache aside, or you can have our cache in line with the actual application server. When you are caching, you want to think, do I need to cache? And if you need to cache, think about, is this service very read heavy? Is it a read heavy workload? Are you constantly reading this database to send information back to your application server to send back to your client? If so, you might need a cache. Are those queries expensive? Do you have a high database CPU? Do you have high latency, or do you have a low latency requirements? Also, when you're caching, you want to make sure you identify the bottleneck, exactly what cache architecture you want to use, whether it's cache aside, the cache in the application server. You want to set an eviction policy. So, how long before your cache is flushed out? What is the TTL for your cache? And then you want to address all of the downsides like stampeding that we talked about earlier. This is also when you can get into sharding. And so as you can see, we have multiple instances of this cache. You can also have multiple instances of a database. But when you have multiple instances, it is called sharding. And when you are sharding, you want to think about, what are you actually going to shard by? And how are you going to distribute that data, which is called your cross-shard operations, and maintain consistency across shards. So shards, what to shard by? What to shard by means basically, say you have a application and you have users that are put in a database based on how many followers they have. So you have one cache for users that are 0 to 1 million followers. You have one cache for users that are 2 to 5 million. You have another cache of users that are 5 to 10 million. So that's what you're actually sharding by. So that means you're sharding by followers, and then the distribution is the distribution of those followers. And so as you can see, there's kind of a problem with this. What happens if this cache starts to be very popular? Say one of the followers is Drake, and your cache has a bunch of Drake hits, and it's getting Drake hits all the time for users requesting information about Drake. Well, what you can do is, so your cache doesn't become overloaded, you can actually store any hotkeys in a cache that's actually in your application server. So for all, say, celebrity, this is called the celebrity effect, for all information that is very important or information that is constantly being searched for, you can put that right down here and make sure that every time my user is asking for a commonly searched for celebrity information, say a Drake, it hits this hotkey cache that has all of my hotkeys stored for very important or commonly requested information. And so that's a little bit about caching and sharding. Going back to our high-level design, this is a good way to think about how to design any web application. You want to start with just the flow of your application, and the data flow really helps here. As you can see, user creates an account right here. The user can read balances of a posted address. The user can deploy community pools, fund community pools, and withdraw from community pools. And the user from here can see the recent transactions of that community pool with all community pool with all community pool information going to the community pool database over here. Boom. And so we have our high level design. We went into some deep dives on where we can handle scalability, where we can add memory caches like Redis, where we can handle stampede possibilities. We can bolster our security by adding know your client and anti-money laundering processes. We can also handle security of our application by limiting the rate of request and putting some additional headers on request so that our application is not being overrun with said request. And so I think this is pretty good wireframing. This is pretty good high level design. And we went into some deep dives. This would definitely get you a lot of points in a system design interview if you were able to start with a simple idea and get all the way to this high level design with some deep dives. And so next session, we will start building our application. I'm going to go through the tech stack that I'm thinking about using. I want to make sure that this entire process is a very transparent application development process, and I want to take all of you on the journey with me. So if you like this video, make sure to like and subscribe, support the channel, share with your friends. Comment below if you have any questions regarding system design. I think this is going to be a pretty interesting series, and we're going to learn a lot together. I'm definitely already learning a lot just by putting my thoughts into words and then presenting them to you all. So thank you again. You've been watching another rendition, another video from Simulacra. I'm Bryson. Hello everyone, welcome back to Simulacra. I'm Bryson, and this is session 3 of building a decentralized application. In the first 2 sessions, we went over all things system design, and today, in this session, we are building. So we're gonna go through any tools, toolkits, libraries, databases that I'm using, languages that I'll be using, and we'll start building the overall services for this application. We're going to really get into the weeds and start building this app. So I hope you stay tuned. I hope you learn a lot. I know I will. Enjoy session 3. The AI editor that we're going to be using for this project is going to be Cursor. Cursor is a really, really good IDE and AI code editor that makes developing applications, web applications, really seamless and really easy. So all you have to do is go to cursor.com and then download. I'm on a Mac, so it's telling me to download for my Mac. We'll download and install Cursor on as an application, and then we'll move to the Cursor application. So this is what the Cursor application looks like. You can clone a repo, connect via SSH, or open a project. We're just going to be opening a project. As you can see, I've already created a project community pool in my GitHub projects on my actual device on my Mac. So we're going to open up our project and get started. When thinking about developing this application, I wanted to make sure that I was using a good developing environment that would help me develop a very robust and secure app, but would also allow me flexibility and speed with development. And so right now we are in Cursor, and I'm sure all of you have heard of Cursor, but if you had not, it is basically a AI agent coding editor that helps you develop applications, debug things, plan out development at a very, very high speed. So right now what we're doing is I have created a folder for my repository on my local repository. And then I have also created a GitHub repository named Community Pool. And I am checking that we can push any changes up to our actual GitHub repo from our local repo. So right now, Cursor is taking me through a plan to make sure that the local repository can be pushed up to GitHub so that all of our changes can be seen by the public, because this application will be hosted on GitHub. The source code and everything will be hosted there. So I think this plan is good to go. Right here, I am just telling the agent that okay, I understand and agree with this plan. So we will test to see if we can start pushing our changes up to GitHub. Okay, so our agent did a couple of things to make sure that we can push and commit to a GitHub repository. So first, it created a dedicated repository in that community pool folder. And then it verified that committing works. It then attempted to push, and this push failed. And the reason it failed was that we had an invalid username or token. Password authentication is not supported for Git operations. So basically down here, that means that we do not have a personal access token. And basically, a personal access token is just a token that ensures that your repository is suitable for personal API use and for using GitHub over HTTPS. So what we need to do is we need to come to GitHub and generate a fine-grained token for our repository. So all I did was come to GitHub and I went to settings, and then under settings, I went to developer settings, and then down to personal access tokens, fine-grained tokens. And so I'm going to generate a personal access token. So I'm just going to name it community pool, since that is our project name. I don't need to give it a description right now. I set the expiration date to 60. You don't want to set an expiration to no expiration, because as you can see, you want to make sure that your information remains secure. So you want to actually set an expiration day. I'm just going to go with 60 days. Also, you want to make sure to only select the repository that you want to generate the personal access token for. You don't really want to have a personal access token that has access to all of their repositories. That's a pretty big security risk. So you can think of, we can keep the blast radius very small if something happens and our personal access token gets leaked for some reason. So we're going to generate that token. And then once we generate this token, we will be able to use this immediately, and it will expire on Sunday the 26th. So once we get our token from GitHub, we can just come back to Cursor and perform a normal git push command. We will be prompted to insert our personal access token, and then after that, we should be able to push all of our local changes up to our GitHub repo so that everyone can publicly view all of our changes that we've made. So it looks like in my normal terminal, I'm actually having problems using this HTTPS with a personal access token. So I'm just going to use SSH instead, and hopefully that will definitely solve the problem. So SSH didn't work because we need to create a new SSH key. We'll then add this key inside of our terminal to an actual pathway, and then we'll actually add the key to GitHub also. And so the way you add a key to GitHub is that you go to your GitHub, and then you go to settings, you go to SSH and GPG keys, and then you will add a new SSH key, give it a title, you'll add in the key, and then you'll press add SSH key. Okay, so I added my key to GitHub, I tested and pushed again, and I got and successfully authenticated in my actual terminal. So that is very good to go. And then now that I have changed into that directory for community pool, and then again push the origin connection test, I am seeing in my terminal that I can now create requests to push this project up to my online repo. So I think we're good to go in terms of now starting to actually generate our services now that we can push our changes up to GitHub. And now for the last part of our setup, setting up our IDE, we want to add some extensions. And some of these extensions are going to help us develop faster and more efficiently and with better format. So we're going to add a few language support extensions such as the Solidity formatter, a Rust analyzer, and a Go developer. And these are going to help us with code completion, imports insertion. They're going to help us with semantic syntax highlighting and essentially formatting our languages that we will be programming in. So one of the first extensions that I want to use is a Solidity formatter. So we'll just type in Solidity format over here, and this first one by Nomic Foundation is the one we're looking for. We're going to open that, make sure that it is by hardhat.org. Cool, we're downloading the right one. Let's install that. Trust Publisher and install. All right, so cool, we have our Solidity formatter installed. And so our Solidity formatter is basically going to take all of our code that is written in Solidity and format it in a way that the compiler can read. And so next, let's add the extension for a Rust analyzer, and we're going to do the same thing as we're doing with Solidity, but with Rust. So let's see if we have a good Rust analyzer. I want to use this one right here, rustlang.org. And basically, this provides support for the Rust programming language. It allows code completion, definition and implementation type, references, semantic syntax highlighting, and a host of other features. Add this Rust analyzer and install. And we're going to trust the publisher and install. So now that this is installed, let's install our last program language formatter. And this is going to be an extension for Go. And we're going to use the Go Lang development support for Visual Studio Code. And it's going to do all the things that the Solidity formatter and the Rust analyzer is doing also. And it's going to make programming with Go way easier and more efficient. So let's install this also. Again, we're going to trust the publisher and install. Boom. So we have all of our language coding and language programming support extensions installed. And so also what we're going to install is a better TOML to be better formatted for our Foundry TOMLs. And this is going to help us when our code needs to be easy to be read and written with obvious and straightforward syntax. And so a TOML extension helps us with this. So I'm going to look for a TOML extension over here. And usually when I'm wanting to install extensions, I look for the extension that has the highest number of uses or installs or downloads, and then also the rating next to it. So we have two even better TOML down here, and then we have better TOML right here by Bungie C and then Nama Safi. So I'm going to go with the even better TOML right here. It looks like it has a lot of downloads and a decent rating. So let's add this so our TOML files are better formatted. And again, we're going to trust the publisher and install. And then lastly, we want to make sure they install the extensions for our actual AI code editors. So we're going to use Claude by Anthropic to help us edit and code our app. So let's install here, Claude Code for VS Code. And I believe I'll have to sign in using my Claude Pro Max account. And again, we're going to trust the publisher and install. And so now we'll wait for Claude to install, and it will likely ask me to sign in. All right, so now that Claude Code is installed, once we start coding actually in the terminal below, down here, Claude will request that I put in my password and username to start using the Pro features. I think that is everything we can do in terms of setting up our IDE. We're using Cursor as our actual IDE, and then inside of Cursor, we are using the Claude Code extension to write our code. And so with that, all of our extensions are good to go. Our IDE is good to go, and we have made sure that we can push all of our changes up to our Git profile so that everybody in public can see. And so that's the setup. I hope you guys enjoyed session 3 of building a decentralized application. If you have any questions about setting up an IDE, what tools to use, and so on, make sure to comment down below. And in next session, we're going to get into some programming and building this application. and all of the services that we can then tie together and put out a full product that we can deploy. So I hope everyone enjoyed. I'm Bryson, and you're watching Simulacra. Bye, everyone. Hey everyone, I'm Bryson. Welcome to Simulacra, and this is session 4 of building a decentralized application. Last session, in session 3, we chose and set up an IDE, and we made sure that we could push our changes to GitHub. So, in today's session, we are starting building the components, the main components that will make up our application. So, I hope you learn a lot. I know I will learn a lot. Stay tuned. Post any questions you have below in the comment section, and let's get into it. All right, so the first thing that we need to do in developing this application is we need to start with a front end, and we need to start with a framework that helps us build a front end more easily. And we're gonna go with Next.js, super easy installation, and we'll be able to spin up a local host web page, and we'll be able to look at all of our changes that we're making. So in our terminal, we're going to copy and paste the command from Next.js, and it's just npx create next app latest. Okay, and we're getting a command not found npx. Why am I getting a command not found npx? Let's see. So we got a command not found npx, and I'm going to guess that means that we don't have Node.js installed, and Node.js is required to use Next.js. So let's type in node v, and yeah, it says command not found node. So we're gonna have to install node on our computer or in our terminal. So the best way to do that is to use brew, homebrew. We'll do it that way. That's the cleanest, especially since I have a Mac. So let's type in brew v. All right, so we do have homebrew installed, so that's good. So now we just need to install node from homebrew. So we'll say brew install node. All right, cool. Auto updating homebrew, blah, blah, blah. It looks like I have 12 outdated formula, and we're going through. It's installing node for us right now. Pro tip, if you have a Mac, homebrew is a really, really good source to essentially install any framework, library, and whatever kind of tool you need. And they have a huge repository of installs. So use homebrew if you need to install a tool or framework and you have a Mac. As you can see, we're installing a lot when it comes to Node, so we'll just wait for a second. All right, so we got Node installed. Now we can review and see if we have it installed correctly. Yep, we have the latest version. So now that we have Node installed, we can create our Next.js application. So let's copy and paste npx create next app at latest, and Next.js will ask us to proceed. Do you need to install the following packages? We say yes. So it's asking us next what our project is named, and our project is going to be named Community Pool. Community Pool, I need to make sure I spelled that right. C-U-M-M, Unity Pool. Oh, and we got a invalid project name. Name can no longer contain capital letters. So that's completely fine. So we'll just make the P and the C lowercase letters. Community Pool. So we'll name our project Community Pool, just like our overarching project in Cursor and our repository on GitHub. And then it's going to ask us, would we like to use the recommended defaults? And we just say yes, use recommended defaults. So now it's installing all of our default dependencies right from Next.js. Next.js is really, really cool, and it's really seamless and really efficient in allowing you to create apps and view your front end on a local host. All right, so we successfully created Community Pool at users GitHub Community Pool. So now we have a Next.js project. Super cool. And if you go over up here, we can see that our Community Pool project has been created. And if we open this Community Pool project, We see a full project in here, and our page.tsx is where our front end or our web page is going to go, our home page. So we have a project created using Next.js, super exciting. And now we're going to run this project and start working on the front end and making changes and making the UI and UX very user friendly. And now we need to actually test our project. So what we're going to do in the terminal is we are going to ls into our community pool. And ls is just a command to list the contents of a directory. So we're going to go into our community pool, and cool. So basically we can see all of the projects and all of our contents that are also up into the right hand corner over here. So now we're going to change directory into community pool. Cool. So now we are making sure that we're in the community pool directory, and then we are going to npm run dev. All right, so this project was created successfully. You can go to the URL right here beside network to actually go to the home page and see what this app looks like. All right, so let's go to see what our app looks like. Let's follow this app. We'll open this. Yes, we want to open from cursor. So as you can see, it's blank. We actually need to start editing that page.txx file that I was showing all of you earlier. So when we start editing that, and then we will save and then redeploy and rerun, and then this actual web page, this home page, will be updated to our liking with our code changes. All right, so the next thing we need to do is we need to make sure that cursor has rules and then also has access to the documentation for Next.js so that our agents are coding and programming according to the rules of using Next.js, and then they're also making sure that the coding that's being done is accurate because it's using the documentation from Next.js. So in our chat, we can add docs for documentation. We'll add a new doc, and then we can add the documentation from Next.js. So let's go search for documentation from Next.js. All right, so we'll go to Next.js, and we'll just take the nextjs.org docs page. We'll type it in here, and then we'll add that doc, and cool, Next.js docs entry point confirm. And now we have the documentation from Next.js available for the agent to use. And next, we need to implement rules so that our AI assistants in Cursor, the AI agents, know exactly the best practices for coding and developing with Next.js. So what we want to do is we want to go to settings, we want to go down to rules, and we want to make sure that the project rules are turned on. And we can either add a new rule here, but I'm going to add an entire new rules file. So I'm going to go up to our community pool project. I'm going to add a new file, and I'm going to name it cursor rules. And then I'm actually going to go to the directory of Cursor to look up the best practices for using Next.js. So over on this Cursor directory, we're going to type in next.js, and we're going to pick the second one, optimized for best practices TypeScript. So you can review the prompt and see if you want to change anything or if this prompt is going to be helpful for you. But I think this is pretty good best practices for using Next.js. So we're just going to copy and paste this right here. So let's copy. And then next we're going to come back to Cursor and post those rules in our Cursor rules file. So we just posted all of these in our Cursor rules file. And so these Cursor rules will ensure that our AI assistant is using the best practices of being a full stack developer. So we are good to go in terms of designing our simple front end. We're going to get a very simple front end. We're going to make sure it looks good, but we're going to then go and develop the back end and then go back, make sure that the UI looks a little bit better, the user experience is a little bit better, and then we're going to connect both of our front end and back end. And all the while, we're going to be doing testing between each of these steps. So now that we have everything with Next.js set up and we know that Cursor can use the best practices when using Next.js and developing this application full stack wise, now we can actually start giving our agent a prompt to start developing what our front end is going to look like. When you're developing a prompt for your front end, you want to be specific in what you don't want and what you do want. So probably going to take a while to develop this prompt for our agent. So we'll come back and I'll show you the prompt, the plan that the agent will generate, and then the first front end that the agent is going to build for our application. All right, I'm back, and it's been a few days, but I finally got down what I wanted to prompt and give our agent so that we could build this front end. All right, everyone, we're back, and it's been a few days, but I finally decided exactly how I want to prompt out this front end and what prompt I want to give the agent so that we can be in pretty good position to one-shot a pretty decent landing page and front end. Instead of using a prompt, I actually created a PRD, and a PRD is just a product requirements document, and it's essentially exactly what it sounds like. It's a document that tells a user everything about your product. So what exactly your product is, the solution, the audience that solution is going to help, the core entities, the flow of the entire application, and so on, the tech stack, what tools you're using, all the things that we went on in the system design YouTube videos. I'll link that down below. Previously, we just put into document format. So I'm going to take that document and plug it into our chat up here in plan mode, and we'll see what the agent comes up with in terms of a plan, and then we'll start building the front end. So cool, let's do that now. All right, so I have my front. Okay, so I've split my PRDs into front end and back end. So I have my front end PRD in Google Docs. So I'm just going to copy and paste it into the chat, and then I'm going to tell the agent, here is my PRD. So I'm going to assume that our agent is not most likely going to be able to just spit us out a full production ready application right now. There's a lot of testing we have to do. We have to build the back end. We have to make sure the front end and the back end connect. We have to do more testing. So I just want it to really build me a MVP front end, and then we're going to iterate from here. So I'm also going to add in a few images from a Bitcoin exchange app that I was working on previously, because I think I developed a pretty aesthetically pleasing app. So we're going to use some of those screenshots. All right, so we added some screenshots from a previous application I was building. Really just pretty ancillary building type screenshots. I also posted how our connected wallets might look and the integrations when we actually are posting an address or connecting a wallet so that a user can see their token balance. So we have that one, and then we also have something for our portfolio balance. And then we also added another what the total balance and the estimated value of that balance might look like. So this should be a good starting point for our application. And now we're going to actually build. So we're in plan mode over here, and we're good to go. So let's see what the application comes in. Oh, we need to add something else. So we have to make sure we tell it to add changes to the home page in page TSX. So let's see what this says. So I think it developed us a good plan. Let's read through it real quick. Okay, target files, cool structure. Have our CTAs, call to action, login, sign up. All right. It's talking about track BTC, ETH, and gold like we wanted to, up to 50 addresses. We can deploy Ethereum community pools. It's a browser-only wallet. All right, so we at least know that this agent is taking in our PRD and reading it and actually extracting what we want. So now that we went through and verified the plan, we're letting our agent build. All right, so great. So our application is done it says the page is static server component and uses these links, and then it has all of our routes. So let's run this project. Okay, run project. All right, so Cursor ran the project, and to view our app, we can just go to this localhost. So let me pop over to our app right now. So this is what the front end for our Next.js app looks like. As you can see, pretty sleek. I like the coloring. I like the green. Nothing too crazy right now. Very simple. And then we have our footers at the bottom that we can start actually building out. So we have a pretty good base for this application. So I think now, since I have a pretty good base, I'm going to go into the creating a account and creating a user process and flow, and then actually build out the portfolio and community pool pages. And then we will make this front end a little bit more aesthetically pleasing. Right now it's decently pleasing, but we can definitely make it so it's a very nice looking application. But for right now, I think this is a good stopping point in terms of this video and building our front end and showing all of you how to build a front end using Cursor and Next.js. As you can see, it's super easy. Anyone can do it. And if you have an idea, start building. So I hope everyone enjoyed today's video. I'm Bryson. You've been watching Simulacra. Remember to support the channel, share to your friends, like, and subscribe. Comment down below if you have any questions or comments related to building front ends using Next.js, using Cursor, or just application development in general. All right, I'm out. I'll see everyone later. Bye, everyone. Hello, everyone. Welcome to Simulacra. My name is Bryson, and this is session 5 of how I'm building a decentralized application. So this is a series where I bring all of you along with me on the journey to create a decentralized application from idea ideation, user requirement brainstorming, system design, and then all the way to deploying a full production application. And I'm going to show you every step of the way. So in last session, we went over how to develop and create a front end using the Next.js and React framework in tandem with Cursor. And so we created a pretty simple front end, but it was very informative in using Next.js, Node.js, and the React framework. And so today, in session 5, we're starting to develop the microservices and the backend for our application. So we're going to start with the microservice for users in creating an account and signing in and logging up for our application. And then we're going to connect a client's database or a user database that will hold all of our user accounts. And then we're going to start working on the community pool service. And this is our service that will deploy, withdraw, and fund community pools. And so that service will also have a community pools database. And then we're also going to start on our address balances service, where users can post an address and receive the balance of that address. And so that service will also have a database. And so for all of these databases, the user account database, the community pools database, and the address database, we're going to use Postgres. And so Postgres is an open source relational database that handles complex queries and massive data sets. And then the addition of Postgres, of a Postgres database that we're using, is going to be Supabase. And so Supabase is essentially a Postgres database, but it has a managed infrastructure and additional tooling, and then also the database layer remains unchanged. So we're going to use Supabase to house all of our data for our different users, addresses, and community pools. And then we're going to start actually connecting all of these services together to make sure that they can run properly together. And remember, if you have any questions regarding Supabase, Postgres, system design, backend services, comment down below and I will answer any questions that you may have. And so I think with that, we can get to it and start developing the backend for this application. And so I hope everyone enjoys, and let's get into it. All right, so the first thing we are going to do is we are going to make sure that users can create an account and log in. So when we go over to our sign up button over here, we see that the page is not working. So we need to make sure that we actually develop a backend for this page. All of these buttons are pretty static right now. They don't lead to anything. So we're going to start creating our backend for our create an account. And so we're going to make sure that our agent is in plan mode. So now what we're going to do is we're going to tell the agent to create a account page when users press either sign up or get started on the home page. And then what we're also going to do is we're going to add in what we want that create an account page to look like. So I just took a screenshot from a previous application that I was building. And so it's pretty simple. Create your account, username, email address, password. And so we want to make sure that the password has some parameters so we can bolster our security for our application. All right, so the agent created us a plan. The goal is to create a sign up page at sign up or the get started, and sign up on the landing page to create a account flow. It's going through our approach, the page structure, and the styling. And so remember to, when you are prompting with an agent and it's developing a plan in Cursor, remember to review everything that the plan is telling you so that nothing extra is added to your application that you don't want. All right, so I went through this entire plan. It looks good. So now we're going to come up here and press build. And so over here, the agent's going to start building. All right, so it looks like the agent is done. It has created a create an account flow on our get started or sign up page. So let's see what that looks like. Let's say run project. All right, it's going to run our project for us, and we can just press run over here. So let's run. All right, cool. So it says our dev server has been started. So let's open it. So that didn't work. So let's try using our localhost. All right, so that worked. So let's come over here. Let's come to our sign up over here, press sign up. And as we can see, we have your create an account, start your Bitcoin journey with community pool, username, email address, password, the parameters for the password, and then confirm password, create an account. And then we also have already create an account, sign in. So cool. So we have our create an account workflow. It kind of looks kind of wonky, but we can fix that later in terms of aesthetics. But now that we have the create an account page, and now we can implement the sign in or already have an account page where users will go to log in after they've created an account. And so I just opened up the entire web page in a new browser and not just in Cursor. So it doesn't actually look like this. It looks like our screenshot that we put in originally. We wanted to make sure our agent modeled our create an account page after the screenshot we put in. So it does look like that on our page. It is just very compressed. All right, so next we're going to do the same thing. We're going to take my prompt from before, which was this the prompt? We're going to take my prompt from before. We're just going to copy and paste that. We'll come to our plan over here, create an account sign up. So now we're going to create a account login page for when users click on the sign in or login buttons. The sign in or login buttons on the landing page, a screenshot of the, let's say, login to. Account pop-up is attached for reference. Please use this screenshot to create the pop-up. And so we also have a screenshot for the app for the login page. So we're going to add that in now and then tell the agent to run. So this is our welcome back, our login page. Pretty simple. Email address, password, forgot password, and then we have a route back to the sign up, create a page if the user does in fact not have an account already. So we're going to run this prompt and see what the agent does. So let's run. All right, so it looks like we're done. Let's go to the login and see if our agent actually created the login page. So it's going to go over here. We'll press login to your account. We have our email address, password, forgot password, sign in. And then if you didn't really have an account, you can also sign up here, which should revert us to the create an account page. So let's press this and see. And perfect. So it reverts to the create an account page. And so now we have a workflow that allows our users to go to our landing page and create an account and then sign back into that account that they just created. All right, so now that we have the create an account workflow set up, I need to decide if I want to create the user database or start creating the other backend services like the community pool service or the address balance service. I think I might do all of the services at once and then just go and create all of the Supabase databases for each of these services. I think that flow will save a lot of time and make sure that I can connect all of the databases correctly to my application. So I think the next backend service we're going to start with is the address balance service. And this is where a user can post an address, and then that address balance service will return the balance of the address that the user just posted. And so each address will have a unique ID, an address ID, which is the actual crypto address for that address, an address balance, and then a transaction hash ID if the address has a transaction hash. And so our community pools would have transaction hashes because they are constantly getting updated or withdrawn from. And so let's create this address balance retrieval service. And so I'm going to have to make sure that my prompt actually makes sense. And I'm going to do this in plan mode first so I can read what the agent is going to do, agree with it, and then start to actually develop this service. And so let me write out a prompt real quick. Okay, so I wrote a small prompt for the address balance retrieval service. So we're in plan mode, and let's ask the agent to run. All right, so the agent created a plan for us. And so again, I'm going to review this entire plan and make sure that I agree with every single thing that the agent is saying before I just ask the agent to build. All right, so it said that we can access the dashboard by hitting this view dashboard on the landing page. It says everything is implemented that we wanted to implement. So let's click on this view dashboard. Okay, so this is what our dashboard is gonna look like right now. We have an address balance, community pool info. I will probably just delete community pool info. It seems kind of clunky. I'll just have address balance here. And then we have a area where we can search or paste an address. We have an add address button, and then we have our added addresses down here to track the balances. And so right now this service won't really work because we don't actually have the backend. We're not using any APIs from any block explorers to actually retrieve balances, but we're getting a good structure to how we want the flow and the data flow for our app to be. So next we're going to create the community pools page. What we're going to do is we're going to create it on this pools tab up here. Right now, if we click on it, there is nothing here. The page isn't working. So we're now going to build this route out. And so again, we're going to come over here and create a prompt that details exactly what we want our community pool service to look like. And remember, so this community pool service will be able to deploy, fund, and withdraw community pools. We need to make sure that we're adding all of the parameters that relate to deploy, fund, and withdraw. We want to make sure that this entire community pools page is very user friendly so that they can easily deploy community pools and fund them and withdraw from them. Okay, so we created a pretty long prompt for this process, so I'm not going to read it out, but essentially the pools page allows the user to press deploy a community pool. They're then asked what is the name of their pool, the pool description, how much would you like to fund for this community pool. The user is given notes on what tokens can be used. We're only going to use Bitcoin, Ethereum, and digital gold, the PAXG stablecoin. The user is then asked if they want to add additional owners to this pool and if they want to set an expiration date for the pool. And so this entire process is going to be in a slide format where when the user presses continue, it goes on to the next slide, and then they're also able to press a left facing arrow to go back a slide. And so lastly, the user can then press deploy on the bottom right of that pop-up slide, and it will deploy their entire community pool smart contract. And so we're going to make sure that we actually tell the agent not to create this smart contract right now, and so that we can make sure that our smart contracts actually work in the backend. But right now we're just making sure we have the UI, UX, and then the flow of this community pool deployment down. So let's put this in plan mode, and then let's tell our agent what to do, and then we'll review the plan and then have our agent build out this process. All right, so as you can see on the left side, our agent is done building. And so now we can actually click on the pools web page. We can go to the pools page and see if our workflow and our process is how we want it to. So community pools, deploy and manage Ethereum-based community funding pools. I'm going to change that to Bitcoin and Ethereum-based community funding pools, but that's fine for right now. So if we press deploy a community pool, a pop-up, it should pop up. All right, so cool. This is our pop-up. What is the name of your pool? We'll just say community pool March. Since it's March, we can say ABC. We just want to see if this workflow actually works. Let's continue. And so what I noticed already is we don't have a back button. So I wonder if I click out of this, it's going to exit out of my entire deploy community pool. So that's not good. So I want to make sure that the user experience is better than that, but that is a small thing we can fix later. So continue. All right, so now we have our back button. So I guess that makes sense. So how much would you like to fund? I don't really like these arrows on the side. I think they look kind of ugly. So I'm going to change that and just allow users to manually put in how much they would like to fund. But we have the notes at the bottom. Minimum funding amount is $5, and then the available tokens to fund are BTC, Ethereum, and Pax Gold. So let's just say 2. And then also, so what I notice is when I'm typing in numbers, it's not showing these numbers in USD. It's just showing them as numerical numbers. And so that doesn't really make sense. Like, what does 2 mean? I know down here in the note it says 5 USD, but we want to make sure that the user experience is way better than that. And so the space bar should say 2 USD. But for right now, 2 is fine. We have our back button. Let's continue. And so good. So I actually made a mistake and put 2. It's good that the application didn't allow us to go with 2, as we previously said that the minimum funding amount is 5 USD. So we received that error. So that is a really good sign. So let's continue now that we put in 5. All right, next, community pool owners. And this is where you can add additional owners. I need to put a note under here that will tell users exactly what to do. We want them to add the address of the owner that they want to make an owner. So we can just say ABC for right now and then add. All right, and so good. So it adds our owner right here, so we know this address for this owner is a part of the owners of the community pool, and if we remove this, it removes it. So that is working well. The expiration date, we can put an expiration date of, let's say, 06/17, and we'll put 2030. And then we have our note, funds are withdrawn to the creator of the pool even if there are multiple owners. And so we have our pool expiration date. We also need to add a note that this is the expiration date that the pool will expire and the funds will be withdrawn to the creator. And then we should have the note that any funds that are withdrawn with this expiration date are going to be withdrawn to the creator of the pool, even if there are multiple owners. So there's a few little user experience things we could add, but overall, I think I like the flow and how this looks. So let's review. And so we review our pool. We have our name, the pool description, the amount we're funding, how many owners we have. Right now it says none. It's the creator only, and the pool expiration date. And so we'll deploy this. And as I told the prompt, we didn't want it to actually create a smart contract in deploy, so nothing happened. But when we have that smart contract created and deployed, we'll list the community pools under deploy a community pool button. And so I think that's everything for session 5. Today we have created a create an account service, the community pool deployment service, and then the address balances service. And in next session, we will make sure that we can fund a community pool that already exists and then withdraw from a community pool that already exists. And then once we have all of those services, we can create the Postgres databases for each of these services. And so when we're creating the Postgres databases, we will need to actually make sure that I want to have 3 separate databases. The address balance and the community pools database can probably be the same database, but the client account, the user account database probably won't be the same. But we'll get into that in our next session. And so this has been another rendition of Simulacra. I'm Bryson. I appreciate everyone for tuning in today. Remember to buy Bitcoin at any price. It's pretty low right now. Get your Bitcoin for cheap. because in a decade, you'll be kicking yourself. Remember to support the channel, send to your friends, like, subscribe, and comment down below if you have any questions regarding anything I went over in this video. And so with that, I appreciate all of you, and I'm out. Bye, everyone. Welcome to Simulacra. My name is Bryson, and this is session 6 of building a decentralized application. In last session, we built out the user experience for deploying a community pool, and in today's session, we are going to build out the withdraw and fund community pool features. We're also going to build some backend and backend databases for our front-end microservices. We're going to be using Postgres as our relational database, and specifically Superbase. Superbase is a really easy way to create and spin up backends and backend databases in the cloud. So if you have any questions regarding system design, AI development, Web3, or anything that I talked about in today's video, comment down below in the comment section, and let's get into it. I hope you enjoy. So let's review the two features that I added after deploying the community pool feature was added. We have fund a pool and withdraw from pool. And so fund a pool, we just have community name and then the pool address and the transaction ID. Both of these are optional, as really the pool address is what's going to allow the system to match the address to what is on the blockchain that is inherent to this contract, whether it be Bitcoin or Ethereum. And so we need to put in an actual pool address or transaction hash. Right now, I don't have an actual checking system to verify that users are putting in a correct address in terms of number of units or in terms of number of characters and things like that. But I'm going to add those things later. So now we can say how much would you like to fund. I still need to get rid of this really ugly toggle bar. So we can fund a minimum amount, which is 5. So we can do that. And then I added also a current pool balance. This is mock. So if you are deploying to a new pool, then all of these would be 0. Or if you're deploying to an existing pool, they would have the existing balances and the tokens of that pool. So cool little addition that I added there. And then the review of your funding. And then you're able to fund. And so I don't actually have any pool that I funded yet. And so that will be added at a later date. So now we have withdraw from pool. And withdraw from pool also has the same setup as fund a pool. We'll put in random things right here. And so I added a verifying pool ownership loading screen. And this is going to allow the system to verify that the user is actually a owner of the community pool that they want to withdraw from. And so that's going to involve the system checking if there's actually a user. And then once that is verified, it will open up and say verified as user. You can continue. Right now, I don't actually have that background process going on, but when we set up our databases, that will help in knowing who is a owner and what can they do with community pools. And then you have how much you like to withdraw and the same available pool balances down here. And so I would type in the valid minimum amount and then a review of my entire withdrawal. And so I also added some spaces where the application holds open pools and closed pools. And these open pools would be linked to the actual Explorer or the block Explorer with it, whether that be Etherscan or the mempool. And so you would actually be able to click on this community pool and go to the Explorer to see all of your information and the contract that is associated with that pool. And then closed pools for historical reference to look back on. So now that we've created deploy, fund, and withdraw flows, and then also the address balance or community pool info service, and a way for users to log in and create accounts, we need databases for all of these things. And since none of our data is necessarily semantic, as in there needs to be context to the data, a lot of our data is going to be in table format. And so For these kinds of databases, we should use a relational database. For this app, we're going to use Postgres and specifically Supabase to build our backend databases. So let's head over to Supabase now. All right, so this is Supabase. Supabase is a open source way for developers to complete their backend for their applications without having to build and connect and configure a Postgres database. When you're regularly setting up a database, you have to set up the database, the authentication system, file storage, and APIs. And then with Supabase, you can just spin up a project and it's already there prepackaged out of the box. And this saves a lot of time. And we know that Supabase is very secure. A lot of people are using Supabase. 40% of YC-backed companies are using Supabase for their backend database needs. And so I think Supabase is going to be a very good use and tool for our application. And so let's go through setting one up, starting a project, and then making sure that Cursor can connect to Supabase using a MPC, Model Context Protocol, so that the large language model that Cursor is using can securely connect to and use external APIs and different tools and real-time data. All right, so we're on the Supabase website, and up here we'll press Start Your Project. And I'm going to use GitHub since we are pushing our Cursor project to GitHub. And so I think it makes sense to also have Supabase have access to that same GitHub. And so we already have access to it. So let's authorize Supabase. And so you may be asked to create a new organization, and organizations are just a way to group your projects together. So I'm just going to name mine Bryson's Apps, and this is going to be the organization that all of my applications backends live on. The type you can just choose as personal or any of the ones that best fits you. I'm just going to go over personal for right now. And then plan, we're going to start with the free plan. So let's create an organization. So now it's asking us to create a new project. So my project name will be Community Pool Dev. And I'm using dev because I want this to be the development environment for my backend for this application while we're building it. And then I will create a new project called Community Pool Production. And that's a way I'll be able to separate my environments so that I can make sure that my users are getting a really good product in production, and I can do all of my development without having to bring down production or alter production in any way. And I can make sure that my changes made to the development environment actually work before pushing to the production environment. All right, so we're on the Supabase dashboard for our Community Pool Dev environment. And so we're going to want to make sure that we add a MCP to Cursor from Supabase, or you can do it the other way where you're in Cursor and you would add Subase's MCP to Cursor. So up top where it says connect, we're going to click connect, come over to MCP, connect your agent. We're going to click Cursor because that's what we're using, and then we're going to add Cursor by directly clicking this link right here, or we can actually add this configuration to a mcp.json file in Cursor and then save. And then also there's an optional install agent skills, which basically just has instructions and scripts and other things that will make Supabase work more accurately on Cursor. So I'm probably going to install that also. But let's click add to Cursor, and then it will ask you to open Cursor, and we already have Cursor open. And now we have to authenticate our connection. So let's press that, and then on my other screen is going to open up a Supabase screen, which is going to show authorizing API access for Cursor. So we want to authorize Cursor, and then it will ask us to open Cursor back over here, and then it should load all of the tools that Supabase uses. And so cool, now we have Supabase authenticated and installed through MCP. And now we can look at some Supabase tools that Cursor can use through this MCP connection. So tools like list tables and get logs will allow the agent in Cursor to output the database entries and the types of databases we have really easily. And as you can see, Superbase has a ton of different tools that you can use. So now we're actually going to develop a prompt to set up a database now that we have the MCP connection to Superbase from Cursor. And we're going to have the agents set up a database for when the user comes to the application and creates an account, and then also for the community pools when a user deploys a pool. And so I'm going to write those prompts and then show you exactly what I prompted the agent and then what it's going to output in terms of a database. And then we're going to go into Superbase and see our database live and test it. So we're going to start a new chat because we are starting a new context. And in this chat, I'm just going to have a pretty clear and simple prompt to use the Superbase MCP to connect to the existing project that we just created in Superbase Community Pool Dev and set up a connection. And so I also created a .env file for the Superbase password when I set up an account for Superbase. A .env file is just a plain text file that is used to hold environment variables, APIs, database credentials, port numbers, and other sensitive information that you don't want to include in your actual code. And so we'll put our .env file inside of our get_ignore file for the type of files that we need to ignore. And so your get_ignore file is all of the things that you do not want to push up to GitHub. And so it allows all of those sensitive details and sensitive information features to remain on your local device. And so we're going to let the agent plan out this prompt and then see what it comes up with. And so it looks like our agent is telling us exactly what we want it to do. We are going to link the MPC to the community pool dev in Superbase, and then we're going to get the project URL and keys and then update the .env file we've made in the community pool project in Cursor. So I'm going to build and let the agent do its thing. So next we're going to actually set up the database in Superbase, but using the agent in Cursor. And I've already created a prompt to post for the agent so that we have clear instructions on exactly how to create this database in Superbase. And so we have this login feature with Superbase authentication. And so we have an overall title of set up this user account creation and login feature with Superbase authentication. In the notes section, we want to use our existing UI components for sign in and log in and sign up. So as you can see over here, I have a way for the user to sign up and then log in if they already have an account. And so we want to make sure we use our existing UI components for that piece. So then we're going to use the Superbase MCP and we're going to create a user profiles table so that the users can have individual accounts when they sign up. And the application should look different for each user's account. And so we'll get into that later when we talk about row level security. And so for right now, I just want the user profiles table to have the username, email address, and password. And then of course, we will add in some other aspects of our Know Your Client policies later when the user goes to make their first deployment for a community pool. We also want the agent to create a pop-up model after users sign in or log in so that users have to authenticate their accounts with a generated code that is sent to their email. So if you've ever signed into any account and you get a code, whether you're signing into your bank account or you're signing into some other authenticated service, and you go to your email that you then have to put into the application, we're going to have that exact same security measure here. And then we're also going to make sure that our application has row level security. And so row level security is just a database and data analytics security feature that restricts data access at the row level based on the user roles, the permission, or the context. And so row level security is pretty simple. It's basically just making sure that you have policies so that users can only see and modify their own accounts. And so you might have a system-wide database where all user profiles are located in that database, but row level security allows each user to have an individual account that they can actually make changes to. And those changes will only show to that user on that account. And then I also told the agent that the .env file with the keys, the Superbase anonymous keys and the URL key already exist. And so our agent will have access to all of the keys and passwords that we need. So let's let the agent create a plan for this prompt. We'll run the plan and then we'll get to test if our database is actually live in Superbase. And when we sign up for an account on the community pool application, it sends us through an authentication process and then signs us in. And then we can see the different accounts listed in our user profiles table on Superbase. So we're back in Superbase on the dashboard for the community pool development project. And so we're going to go to the left and go to authentication, and then we're going to go down to URL configuration, and you're going to put in your site URL or your development URL or your production URL for your application. So we already did that. And then I also added that URL as my redirect URL so that the authentication providers were permitted to redirect to post that actual authentication. And then next you want to go up to sign in and providers, go over to email, and then make sure that your enable email provider is on. And so this enables that there is an email-based sign up and login for your application, and that there is some sort of authentication for when users sign into your account. And then there are also other settings that you can use, minimum password length, the requirements, and so on. I set mine for 10. I think in my application it says 14 right now, but I'm going to set 10. I think that's a good password length. And then we have the required symbols and digits, the recommended one, so that our password is very strong. And then the actual length of the numerical code that the application will send to users when they're authenticating their sign-in. So now that our agent is done with the prompt we just gave it, we want to test if the application sends users a numerical code when they're signing up or logging back into the application. And then we want to see if those created accounts are populated in our user profiles table on Superbase. So let's sign up for an account. We'll pick Satoshi. All right, so a confirmation was sent to my email, but it wasn't exactly a code confirmation. It was simply a link saying follow this link to confirm your user, and I confirmed that using the link. I want it to be a little bit more secure in that the system will make the user put in an actual 6-digit code, but still having them confirm to a link on their own account means that the user that is using this email to log into my application actually has access to the actual email that is being used. And so I'm okay with that level of security right now. So let's see if we can log back into the application using the credentials that we use to sign in. And then we'll go to Superbase and see if that user is actually populated in the user profiles table. So back in Superbase, if we go to authentication and then we go to users, we can see that we now have one user, Satoshi, display name, email address, the email they provided, and then what date they were created at, and then some other things we can do with the user, such as delete them, ban them, and reset their password from Superbase itself. So in today's session, we were able to set up databases, back-end databases for our application, and we set up a database for the create an account service. And then in the next sessions, we're going to be setting up our databases for the address balance and then the actual community pool deploying funding and withdrawing services. So I hope you learned a lot about Superbase and backend databases and how easy it is to set up your own database for your application. Ask any questions that you may have down below in the comment section. Remember to support this video, like, subscribe, send to your friends, and you've been watching another video from Simulacra. I'm Bryson, and I'm out. Bye, everyone. Welcome to Simulacra. I'm Bryson, and this is session 7 of building a decentralized application. In last session, we went through everything Postgres and Superbase databases. So we set up a database and connected it to Cursor via MCP, Model Context Protocol. We then prompted the agent to build out the database schemas for our user profiles database. And then we set up user authentication and made sure that each user had row level security, meaning that each user can see the changes that they made to their account and only on their account and not system wide. And then we configured Superbase authentication settings and went through the testing and sign up flow and verified that the users were actually in the Superbase dashboard after creating an account on the application. In this session, we're also going to test that users can actually take their crypto address, whether that be from a wallet or an exchange, post it into the application, and retrieve a balance using APIs from the Block Explorer, whether that be a mempool or other Block Explorer based on the blockchain and the token address that the user is trying to receive the balance of. So I hope you learned a lot from today's video. Remember to like and subscribe. If you have any questions or comments regarding Web3, AI, Bitcoin, or what we go over in today's session, leave a comment in the comment section below. And so I hope you enjoy, and let's get into it. All right, so over in Cursor, we're going to start a new chat, and we already created a prompt for setting up the user crypto address balance retrieval database. And so we're going to post that prompt into the chat, and then we're going to change to plan mode so that the agent can plan out what it wants to do, and then we'll review the plan and then let the agent build. So the prompt is pretty similar to the first prompt we used to set up the database for the user accounts profile. Instead, we're setting up a database for user address balances table. It's going to have the username, the actual address ID, whether that be from your wallet or an exchange, the address balance, and then the transactional ID. So the address ID is meant to be refreshed every time that the user manually refreshes or reloads the page so that they can have an updated address balance for the address that they posted into the application. Again, we're making sure that the users have row level security so that only the addresses that they're posting on their account they can see on their account, and user system wide don't see addresses from other users. And then also we're telling the agent that we have that environment variable file with the Superbase keys that already exists so that they can use the Superbase MCP to create this database. Okay, so the agent has notified us that it's done setting up the user crypto address balance retrieval database, and now we want to set up the community pool database for when users deploy community pool, they should be able to view all types of information regarding their community pool. And so we're going to paste in the same chat. I wrote up a prompt for this also, and we're going to have some of the same things in the prompt from last prompt. It's going to seem redundant, but you want to make sure that you're telling your LLM repeatedly what to do over and over again so nothing is missed in translation or interpretation. And so again, we're going to have the agent use the Superbase MCP to create a user table so that users can view information regarding their community pools. We gave the agent some of the columns that the user pool database should have, and then we also mentioned row level security and mentioned that the .env file exists again. And so let's put this in plan mode, see what the agent creates as a plan, and then we'll start building and deploying this next database. So now that our agent built both of our databases that we wanted to build, the user pools database and the address balance retrieval database, now we need to check in Superbase to see if our databases were actually created. So we're on the Superbase dashboard. We're on the dashboard for our community pool development page. And so we're going to go over to the left. We can go to table editor, or you can go to database, but we'll go to table editor. And as you can see on the left, you can see the two databases we added, user pools and user address balances. So if we click on user pools, we can see all the columns that we wanted the agent to create: the username, the address ID, the pool balance, the token types that are in the pool, the transaction hash ID, when the pool expires, the minimum fund, the maximum funding amount, the supported tokens. I think the supported tokens and the token type are probably redundant, so I'll have the agent delete one of those, and then any metadata about the community pool. And if we go to user address balances, as you can see, it also has all of the columns that we wanted the agent to create. So now that we have our main databases created, we want to test to see that a user can actually come to this application, create an account, and then paste a crypto address and retrieve the balance of that crypto address, which will be shown down below. And so to do this, we'll need to set up some RPC nodes using APIs from the different block explorers and mempools so that we're actually getting blockchain real-time data and not just fake data that our application is telling us is there, but it's not actually there. We want to make sure users can actually retrieve a balance from the crypto address they posted. So I think the best way to do this is to use a test MetaMask wallet that I have, put some Sepolia tokens in it. Sepolia tokens are basically just test tokens that don't actually have any value but allow developers to develop using tokens that they can actually send to others, and you can actually see these transactions on the block explorer. We're going to set up a plan for architecting the RPC nodes so that our application can actually talk to these different blockchains. For that, we're going to use Alchemy. Alchemy is a good way to spin up development environments using blockchain nodes to test on testnets, and then it also has a mainnet feature we can switch to once our testing is done and we've made sure that our application retrieve balances like we want to. All right, so this is a very important part of the app. It looks like we have our front end good to go. We know our process and how we want the user to interact with our application. And then we set up the databases on the back end in Superbase as our Postgres databases. And now the most important part is connecting those two ends and making sure that our application actually does what we want it to do. We want to make sure that the users can go to the application here in the address balance community pool info section and post their address and actually get valid information back, such as balances. And so I previously mentioned that we're going to use Alchemy. It's a really good tool in the Web3 community to help us with this task. And so I came over to ChatGPT because I really wanted to get a full functioning prompt together before I went back into Cursor to let my agent start building. And so since I know that I am going to use Alchemy, I wanted to have ChatGPT develop a prompt that was going to take the documentation that I gave it from the Alchemy different web pages and format it into a prompt for this application. And so I just asked ChatGPT, can you develop me a prompt for the Cursor agent to build out the crypto address balance retrieval service for the app? I'm basically telling it that the front end is done, the back end has the Superbase databases, and the database for the user address balances will be called user address balances, and just develop a prompt so that Cursor can build so that users can actually paste an address and receive the balance for that address. And then I made sure to go through all of the Alchemy documentation on connecting to RPC nodes and APIs using Alchemy, getting tokens from a wallet, how to get transaction history for an address on Ethereum, the token API quick start, and pretty much all of the documentation that has to do with this process. I pasted all of the documentation into ChatGPT here, and then I also gave it an overview of the different topics down here. So let's see what ChatGPT generates, and then we will review and then go over to Cursor to start building. Okay, so ChatGPT responded with a very extensive prompt for me to put into Cursor. I've reviewed it and I like everything that ChatGPT suggested. I think I'm probably going to put this into Cursor in chunks so that the agent doesn't get overloaded. When you're working with agents or LLMs in general, you want to make sure that you approach it with an iterative approach. You don't want to give the agent too much context because that is a huge bottleneck. And I think actually this prompt might be just long enough that we're not going to run into context issues. So I'm going to copy this prompt into Cursor, and then I'm also going to give my agent in Cursor access to the documentation in the pages above from Alchemy so that the agent knows exactly how to build out the process of fetching a crypto address retrieving the balance, and then returning it to the application, and then storing it in our database. So now that we're back in Cursor, we're in a new agent chat. We're going to paste the documentation from Alchemy into the agent so that it can reference the documentation. So let's go to @docs in the chat. You're going to go to docs or @docs, and then I'll press add a new doc. And then just going to paste the URL of the documentation that we want the agent to reference. So let's go through each one. And I'm going to actually name the doc based on what doc it is, because I assume that I'm going to have to come back and reference these documents again. And so I want to be able to just say @alchemy get started, and this document will pop up when I want to reference it. So let's confirm this, and then let's do the documents for the rest of the pages. All right, so we just got done adding all of the documents from Alchemy, and then we also added our prompt from ChatGPT. We're in plan mode, so we're going to have the agent review this prompt. We have this prompt broken up into 2 phases, so we just have the first phase first, which is just to inspect, plan, and then propose the architecture. We'll have this agent plan, we'll build, and then we'll go into the next phase 2, which is the prompt that actually lets the agent know what they're building and implementing. All right, it's saying planning next moves. I assume this is going to take a while because I gave the agent a lot to do. So I'll come back with the results of our phase 1 for building out the crypto balance retrieval service. This provider adapter architecture is a really important part of the plan. I want to make sure that Cursor directly knows how this flow is going to go. So essentially it has our flow as classifying the input. So is this a transaction hash, or is this a crypto address and Ethereum network address, or is it a Bitcoin network address? And then we have an orchestrator, and then here we have our 2 adapters, and that's going to be the deciding factor in what balance gets returned. And then also a very important part of this plan, all of the files that are going to be changed, you want to make sure that any files that you don't want to be changed are not part of this list. And then for this .env file down here, it says .env.example, but I think the agent is looking for the API keys from Alchemy. So we'll have to go into Alchemy, generate a new API keys, and then update our .env file so that our application can send requests to Alchemy. This is the dashboard that you will see when you create an account in Alchemy. You can use a endpoint URL, and then they have a curl request that you can use to actually build with. We're just going to put our API key up here in our .env file so that our agent and Cursor has full access to our Alchemy dashboard and endpoint URLs. And so one thing to note when inputting this information into your .env file, your API key over to the right, I'm not going to show you because I need to keep this secure, is not going to change depending on the network, but the endpoint URL will. So you'll need to put in the endpoint URL for each network that you want to use in your application. So as you can see, Ethereum mainnet has this endpoint URL for Alchemy, and if we go to Bitcoin mainnet, the endpoint URL will change. All right, so we updated the .env file with the API key from Alchemy, as well as the endpoint URLs for Bitcoin mainnet, Ethereum mainnet, and Ethereum Sepolia. So that should cover all of the available tokens that we can use on our application, which is Bitcoin, Ethereum, and PAXG. PAXG is the stablecoin for gold, and it's a ERC20 token. So it is compatible with the EVM network. And so right now our agent is moving through the plan and completing the tasks that it generated from our phase 1 plan. This has taken a while. It's been about 5 or 10 minutes, but we want to give our agent a lot of time to build out so that we get a really good result. All right, so it looks like our agent is finally done building. It took a good 20 minutes to build everything out, even though I split up the prompt into two phases, but we wanted to make sure that the agent doesn't cut any corners in terms of building. And so both migrations were updated in Superbase. via apply migration. The user address balances was updated with the on-chain column, and then also with the lookup metadata. And I'm looking at Superbase right now, and I can see those columns have been updated in Superbase. And so if we come over to Superbase, we can actually see in our user address balances table that the agent has updated on-chain snapshots, when these snapshots retired, the input kind, and a host of other columns that are related to our users posting a crypto address and retrieving the balance for said crypto address. This snapshot expires at column is especially important because the users will be constantly refreshing the balance that they're retrieving. And if the balance is stale, then we want to make sure that we have a column to show that this balance is stale. And when the application refreshes, we're going to get a new on-chain snapshot that has a new expiration time. So now that our agent says everything is good to go and we've confirmed in Superbase that our columns are updated, we're going to take some crypto addresses and we're going to paste them into the application. And we're going to see if we can get a balance back from that crypto address, and then that balance can be stored in our database. And then we want to make sure that we can store multiple balances and multiple addresses per user. And so I'm going to do all of that testing. Remember, if you have any questions regarding what we talked about in this video or questions about Web3 or Bitcoin or AI in general, post in the comment section below. This has been session 7 of building a decentralized application. I hope you all enjoyed, and I'm out. Bye, everyone. Welcome, everyone. You're watching Simulacra, and I'm Bryson. This is session 8 of how I'm building a decentralized application. Now, in today's session, we're kind of doing a lot. We are going over how oracles work. We're setting up the Chainlink price feeds in the application. We're going to build out the price converter and some of the other code and source code for the community pool funding, deploying, and withdrawing, as well as some of the other helper config code files that will aid in our application being able to deploy smart contracts to the blockchain. We're also going to go over getting test tokens and setting up a demo wallet in MetaMask, and then we're going to live test posting a crypto address and retrieving the balance for that address in the application. And remember, if you have any questions regarding anything that we go over in this video, remember to post that question in the comment section below. This will be a great session, and I'm ready. So let's get into it. So today's session is all about testing. We need to test and make sure that our backend actually works, that users can actually deploy a community pool, and users can post an address and receive a balance. So first, we're going to test if users can post an address or a transaction hash and receive a balance from that address to their balance list. And so to do that, we're going to need to get pricing data, price feed data from an oracle. And an oracle is just an entity in the decentralized finance world that allows on-chain data to interact with off-chain data. So the oracle that we're going to be using is called Chainlink. Chainlink is a very useful and secure oracle. So this is how it works. Chainlink nodes get data from external data providers or exchanges. That data is then brought through a network of decentralized nodes, and then the Chainlink decentralized nodes uses a medium to figure out the actual price of the asset and then delivers the information to a smart contract. And this smart contract is called a reference contract or a data contract or a price feed contract. And that contract, that smart contract, is on chain. And so this allows other smart contracts to use the data from the reference contract and price information to power the decentralized application. To get actual price data from Chainlink, we can just go to chainlink.com. This is the dev hub for
Chainlink, we're just going to go to resources, and then we're going to go to docs. And here is all of the information regarding the Chainlink data feeds. So they have overview, get started, feed addresses, price feeds is where you'll go, and you can come down, and as you can see, we have mainnet and testnet, and then we can go between the different networks to get different addresses. And the address info will just be what the pair is. So if we go next, and then we go next, let's see if we can find Ether to USD. We'll just use Bitcoin to USD. And so if we wanted to get price information of Bitcoin related to USD, we would take this address and use it in the smart contract that we're developing on our application, or we would give this address to our agent to build out the file for retrieving balances from an address. And so this is not the address we're receiving balances from, but this is the address that will help us retrieve the balance in terms of USD, and we're getting that pricing information from our Oracle network, which is Chainlink. So back in Cursor, I already created a folder for where all of the tests are going to go. So I'll open this and I'll create a new folder inside, and we'll call it price feeds. And inside of price feeds, we'll create a file, and that file is going to be called V3 aggregator. And V3 aggregator is just a price feed aggregator that was from the Chainlink documents website. And we'll say it's a .sol because it is a, and we'll name it a .sol because it's a Solidity contract. So cool. So that opens up the V3 aggregator file. And so that opens up the V3 aggregator.sol file. And I have already written up a smart contract for this process before. And so I'm just going to use my smart contract from another project and then paste into Cursor. And so I've already created this file for our V3 aggregator.sol. I used the template file from Chainlink and then made modifications for another project when I was trying to get the price feeds for Ethereum and Bitcoin. So I'm just going to paste that into Cursor. And as you can see, we are writing in Solidity, and the file is importing the aggregator V3 interface from the pathway at Chainlink. And if you go to this pathway at Chainlink, it will take you to their GitHub where you can view their example V3 aggregator file. And so now that we have this V3 aggregator.sol file, now we can import and get price feeds from Chainlink. And so we'll need to also create a price converter.sol smart contract in Cursor so that our application can actually take the prices from. And so now that we have the V3 aggregator.sol in Cursor, we also need to create a price converter file so that our price can be converted correctly. As it is right now, when you retrieve a price feed from Chainlink, and so when we get the price feeds from Chainlink for the assets, whether that be Ethereum or Bitcoin, we still needed to convert that price to the amount in USD. And to convert that price to the amount in USD, it would be the asset price times the amount of the asset I have. And for Ethereum, it would be divided by 18 digits. And so I'm going to create another folder called source for our source code. And then inside source, I'm going to create a file called price converter. In priceconverter.sol, I'm going to copy and paste the code that will convert our asset price into a price that is actually in USD so that our users can use it. So in this code, again, we're importing that aggregator v3 interface, and we already have that v3 aggregator.sol file in our test folder. And so we're opening up a library called price converter. We're writing a function that goes and gets the price from this v3 interface from Chainlink. And then the get conversion rate function takes the Ether amount and the price feed from the aggregator v3 interface and returns the amount in USD by taking the Ether price times the Ethereum amount divided by 18 digits. And so that will be the actual Ether to USD conversion rate after adjusting for the extra zeros. And then we're going to return the amount of the Ether in USD. Okay, great. So now that we have our price feeds that are aggregated from Chainlink, and we have a way to convert those prices to an amount in USD that is usable for our users, now we need to check if the agent can actually use the two files that we just created, and we can post an address in the application and retrieve a balance now that we have all of our information from Alchemy and Chainlink. Alchemy being our node and RPC infrastructure, and Chainlink providing pricing data. So now that we have the v3 aggregator and price converter.sol squared away, now we can actually prompt the agent to make sure that it can retrieve prices from Chainlink. And then we're going to make sure and test that we can post an address in the application and retrieve a balance. And this should all work because we have our price feeds from Chainlink and we have our node in RPC. If you remember from last video, remote procedure calls allows one program to request a service from another program on a different network without needing to actually understand those network details. And so we have our Alchemy API and we have price feeds from Chainlink. So we should be able to post an address and retrieve the balance. So let's prompt our agent and see if it works. And so I gave the agent a very simple prompt. We're testing if users can post an address, transaction hash, etc., and receive the balance. I'm telling it has access to the Alchemy API keys for remote procedure calls and node infrastructure, and then it also has access to the price converter and the aggregator that I just created. So I want the agent to check if these files work and if the agent can actually price feeds from Chainlink and I want to check if the agent can actually receive price feeds from Chainlink. So let's put this in plan mode and see what kind of plan the agent comes up with. And so this is a really, really good case of where putting the agent and cursor in plan mode and reading through the plan first before you let the agent build is always very, very good to do. So we have two caveats. We have three caveats. It says the scaling is hard-coded to 1 to the 10th. Production code often uses 10 to the 18th minus the uint 256 of the price feed dot decimals. So we have three caveats that the agent said that both the price converter and the v3 aggregator files are good to go. But the scaling is hard-coded to 1 to the 10th. And production code often uses 10 to the 18th and then all of this minus uint 256 of the price feed at the index of the decimals and so on. Also, there's no check that our answers are greater than 0 before casting to that uint 256 value. Also, we don't have a staleness check. So we don't know how stale our information will be at any given point. These prices that we're retrieving could be hours old, and that wouldn't be useful for our users. And so the main things that I really want the agent to do is add the Foundry project under community pool and then start using Foundry to test that we can actually deploy that v3 aggregator.sol. And so I'm going to let the agent do all of these things, and then I'm going to come back and go to the dashboard and see if we can actually get a balance from a crypto address. And so our agent recommends a few things before we start building. It recommends that we use Foundry. And basically Foundry is simply just the industry standard framework for Ethereum application development. You can build, deploy, and test your smart contracts using Foundry, and Foundry can simply be imported through the terminal. You may have to go to Homebrew to install Foundry, but once you have Foundry installed, you can just go into your terminal and say Foundry up, and a Foundry and testing environment will appear. So I'm going to let the agent add Foundry and then do some Foundry testing because I want to really make sure that our smart contracts work and that our application can use real price feeds from external data sources. But the problem with that is that we want those data sources to be decentralized. And so they need to go through a decentralized oracle such as Chainlink. All right, so now that I've explained what an oracle is, I think we're ready to officially test the balance retrieval service for this app. So we're going to go to the landing page, sign in, and then get a crypto address, post it in the application, and then see if we can actually get the balance of that crypto address. And to do that, I'm going to use a demo MetaMask wallet that I have. We're going to go through putting some Sepolia tokens in it. We're going to explain what Sepolia is, and then I'm going to take the address from that demo account, that demo wallet, and post it in the application to see if we can retrieve the balance. So let's go. So to test this application, we need to go get some Sepolia, some test tokens. And Sepolia is just a test network for Ethereum that was launched not too long ago. And it operates independently of the main Ethereum network, but it closely simulates its conditions. So basically, it allows developers to see how their code will behave in a live environment. And the testnet also has its own block explorers and allows users to view those on-chain data specific to Sepolia tokens. So once we go get the Sepolia from the faucet, we can actually go to the Sepolia block explorer and see that transaction being sent to our wallet. And so remember, Sepolia uses test ether, which serves the same purpose as ether on the mainnet, but it doesn't have actual value. So it's only for deploying, testing, building decentralized applications. And so we get fake tokens to deploy to our application to see what happens in a development or production environment. And before, I was trying to develop a application previously, a decentralized application previously. To test it, I sent $10 worth of Bitcoin to my application. And as you can probably guess, that Bitcoin is gone forever. And so that is the power of using test tokens like Sepolia to test your application. So let's go get some Sepolia now. All right, so to get some Sepolia, you can just literally type in on Google Sepolia faucet. And so there's a lot of companies that provide Sepolia tokens. Alchemy provides a faucet. A couple of other these companies provides a faucet. But I always have seen that Google Cloud has worked the best when I am wanting Sepolia, when I am in need of some Sepolia when I'm developing. So we go to Sepolia Ether and we paste our wallet address or ENS name. So that allows me, I need to go to MetaMask and I'll type in my password. And so this is what the MetaMask wallet looks like. As you can see, I already have a little bit of Sepolia in my account. If I go up here, I also have some Sepolia in another account on account 2. And so I will today not actually go and retrieve Sepolia from this faucet. When you are using Sepolia and going to use the faucets, regardless of whatever faucet you use, make sure to seldomly use your Sepolia and just be responsible with your usage in general, because the devs are still putting their time and energy into upholding the infrastructure so that you can use free tokens, because they don't make money when you use free tokens. And so, yeah, remember to be responsible with your Sepolia usage. But if you didn't have any Sepolia and you wanted some, you would go inside of your MetaMask account, go to the account that you want to send the Sepolia to, and then you would come here, and these are all of the crypto addresses, the public addresses for each of the networks. And so since I want Ether Sepolium, I'm going to choose the Ethereum network. And so actually down here, before I do that, make sure that you are on the same network as the token you are receiving or trying to send, so that those tokens just don't get lost in cyberspace, essentially. So cool, we're on the Sepolia network. So we're going to take our Ethereum public address, have it copied. We're going to come over here, and then you would press get 0.05 Sepolia Ether. And once that happens, you would get those Sepolia in your MetaMask wallet, and that would show up here. And so to actually see that transaction on the blockchain, remember, there's still going to be a ledger of this transaction, even though that the Sepolia was free and it doesn't have a value to it. You can still see it on the Ether Scan blockchain, except for Sepolia. So you can just go to Google and type in Sepolia Ether Scan, and this would be the testnet Sepolia Ether Scan blockchain. And then you would paste in your address, the same address that you used to get the Ether Scan that you posted into the faucet. And then Etherscan will list all of the transactions and the transaction hashes for that address. So 111 days ago, I got some Ether from a faucet, and then the rest of these outs are me playing around with contracts and funding contracts and basically practicing to build this decentralized app that I am building now. Okay, cool. Now that we know we have Sepolia Ether in the wallet, we can come to our landing page. We're going to sign up, we're going to create an account, and we're going to post the crypto address of that wallet, of our MetaMask wallet, post it into the application and see if we can retrieve the balance. I think the balance was 0.241 Ether. And so we should see 0.241 Ether in the application. So we created an account. We're on the address balance retrieval dashboard. I'm actually going to come back to my agent over here and tell it that I'm about to post a crypto address in the address balance retrieval dashboard, and to stand by so we can see if the balance will actually be retrieved when I post this address. And so again, I'm going to go get my public address from my MetaMask wallet for the account that I want to get the balance of. All right, so I'm in my MetaMask wallet. I'm going to copy the address for Ethereum because I want to retrieve the balance of my Sepolia Ethereum from this wallet. And then with that public address from my MetaMask wallet, I'm going to come back to my application and post that address and press add address. So it's saving. Let's see what happens. Okay, so our application gave me back, it outputted a few things. So the address slash hash, I'm going to assume that is the same address that I put in, even though it is condensed. It also gave us back the actual type of network or token that was associated with that address. So that's very good. It was a Sepolia Ether address, so that's good that our application recognized that. And then next is the actual balance and amount of the wallet. That is the big thing we want to see. So it says 0.4185 for Ether, And we have that right here, 0.42 Sepolia Ether. Perfect. And then it also says +1 talk and 15 transactions. I'm assuming +1 talk is a token. And I know I have ZK Sepolia testnet in this account. And so I have a little bit of Sepolia testnet. And so I think since the ZK Sepolia testnet is not a part of the actual Ether, is not a part of the actual Ether network, I'm assuming the application didn't return for that reason. So I'm going to see if it will return the balance if I post the crypto address for the ZK Sepolia testnet also. Okay, so its account. Okay, so it seems like my application is counting this Ethereum address as just one address for this entire account because the ZK Sync Sepolia testnet, even though it is a ZK Sync Sepolia, Sepolia is using the Ethereum network. And so I think that's what that means. One token +1 token means I have ZK Sync Sepolia testnet and it's accounting for that. And then 15 transactions. So if we post this address into the Etherscan Sepolia testnet explorer again, we can see 14 transactions, and then if I go to token transfers, we have one token transfer. And it seems like this is 127 days ago. So if we go back to transactions, we have one token transfer, but I don't think that is that because that is us getting because that's us getting Sepolia from a faucet, and this token transfer looks to be a Chainlink token. And so I think that's where our 15 transactions are coming from. I'm going to do some more playing around and tooling to make sure that our application is actually retrieving relevant and accurate information. And then in terms of the balance, well, we know that Sepolia doesn't have a actual value. As you can see, it says 0 right here. So it makes sense that our application would not return the balance in USD of this crypto address. And so I definitely need to do some playing around to make sure that the information is accurate, but I think this is a good indication that the address balance retrieval service is working. And so I'm going to continue to work on that. I'm going to test. I think this is a good indication that the address balance retrieval service works correctly. So let's use another crypto address from this same MetaMask wallet, but a different account, and let's see what happens. So in this account, we have 0.25 Sepolia in here. So we'll take this Ethereum address, copy, and let's post into our application and see what happens. So it's saving. It's saying that this account has 0.025 Sepolia Ether. That is correct. And then one transaction. So if we go back to the Etherscan for Sepolia and we type in that transaction, we can see one total transaction. And so it looks like the application is correctly taking the crypto address or transaction hash, returning the type of network or token that is inside of the wallet, and then returning the amount of token that is actually inside the wallet. And since these Sepolia tokens don't have any value in USD, the application is not calculating the balance in USD. Now, what is to be determined is what will happen with a wallet that has multiple different types of tokens and addresses. I want to make sure that the application will list out all of the different types of tokens that are in the address and their amounts. I don't want it to just list the first one and then +1 token. I'm going to assume our application did that because this +1 token referred to a ZK Sync Sepolia testnet token. And so I want to see if we have Ethereum and Sepolia Ethereum and Bitcoin in a wallet. Will our application be able to differentiate between all of those? And so that's probably going to be a way longer video. I think I'm going to end this session here and begin the next session, session 9, with fully building out how the application will deploy community pools that other people can fund with different tokens, and the owners of those community pools can withdraw the funds from. So I hope you all enjoyed session 8 of building a decentralized application. I am going to get into the next session now and record now because I am pretty hyped that this application is coming along so well. So if you have any questions regarding what we went over in today's video, remember to drop that down in the question section below. Remember to like, subscribe, support the channel, send to your friends and family, and you are watching session 8. This is another video from Simulacra. I'm Bryson, and I'm out. Bye. Welcome, everyone. You're watching Simulacra, and I'm Bryson, and this is session 9 of how I'm building a decentralized application. Now, in last session, we kind of did a lot. It was a very testing-heavy session. We made sure that the entire flow and backend for using the application to post a crypto address and retrieve the balance worked. And it did. We were able to retrieve the balance of a demo wallet that I have in MetaMask. And so for this session, I am building out the entire community pool aspect of the application where users will be able to deploy a community pool, fund that community pool, and then the owners can use their keys to withdraw the funds from that pool. So I'm going to build out the entire backend, and I'm going to deploy the community pool to a testnet to see if we can actually deploy it to a mainnet. We're going to use some Sepolia Ether. In last session, I showed all of you how to get Sepolia from a faucet, so this is going to be a really cool session. So after this session is going to be the major endpoint for the series, and after this, it'll be a lot of front end and aesthetic work that I'll be doing. If you have any questions regarding anything that we went over in this session, remember to comment down below, like, subscribe, share with your friends, and let's get into it. But first, I need to make sure that users can use MetaMask or another injected wallet provider on my application so that they can sign transactions and actually deploy community pools, because it's going to cost some amount of tokens to deploy a community pool in terms of gas fees, network fees, lightning fees, and things like that. So I went to ChatGPT and I asked it to develop a prompt so that I could give it to an agent in Cursor to perform the task of making sure that this application is MetaMask wallet compatible. So I'm going to copy my prompt from ChatGPT and paste it into the agent. Up here, I'm going to press plan so the agent is in plan mode and doesn't fly off and start building. All right, so the agent gave us a plan. I think the plan looks pretty good and goes through everything that I want the agent to do. So I'm going to come to the chat and say at docs, I am adding a new doc. So I'm going to type in the documentation from ether.js, press enter, and then I'm going to confirm this is ether.js so that the agent has access to ether.js. And ether.js is a library that aims to be a complete and compact library for interacting with Ethereum blockchain and its ecosystem. So it's used to create wallets like MetaMask and create decentralized applications and other tools and simple scripts that require reading and writing to the blockchain. So now that we know that our agent has access to ether.js, we can tell it to implement the plan and we'll build it out. So the agent is done. We were able to build out the backend for connecting your MetaMask wallet to our application. So if we go to the dashboard for our application, we can see it says connect wallet. And if we press connect wallet, Oh, look at that. The MetaMask wallet browser extension will pop up, and then you can just enter your password and sign into your MetaMask wallet. So we'll see if this works now. So over on our app, it displays the MetaMask wallet as connected. And then if we go to the MetaMask browser extension here and we type on our account, it says this account is active because it's connected to our application. And then if we click on it and we go to here and manage our permissions, we can actually disconnect from our localhost on our application. So our localhost up here in our URL is the same as our localhost here, so we know that our wallet is connected to our application. So let's disconnect that for right now. So back in Cursor, now that we know that our application can actually connect using an injected provider, and that injected provider being the MetaMask wallet through the browser extension, let's open up a new agent and let's give the agent a new prompt for actually building out the deploy, fund, and withdraw community pool capabilities. And so I have a prompt that I already created that we're going to post into the chat here. And so this prompt is pretty simple. It's just saying to create smart contracts for deploying, funding, and withdrawing community pools. You have access to the file Foundry Practice, which contains the code files listed below. And Foundry Practice 2 is a project I was using to learn how to use Foundry to test and deploy smart contracts. And so I already have the code written up, so I'm just going to give the agent all of those files. And then I'm also telling the agent to make sure that each smart contract for deploying a community pool uses that same flow of the application to create the community pool contract. So we want to make sure that the contract that is posted to the network or the blockchain has the pool description, the community pool name, the fund amount, any additional owners, and the pool expiration date. And then we want to tell the agent the available tokens that can be funded and to use Anvil through Foundry and our Alchemy keys to deploy the smart contract on a testnet and then actually to test to see if that smart contract has been deployed. So let's let the agent build and see what the output is. Now I am going to build out the backend for deploying, funding, and withdrawing from community pools. Okay, so right now the agent is running through testing the community pool process. And so I gave the agent the prompt to use Anvil to spin up a node environment with keys and funds to test deploying a community pool. So I just named the community pool test pool, gave it a pool description, a contribution amount, and an expiration date, and then told the agent to test and deploy this to a Sepolia testnet. So right now it's going through, actually working through deploying our community pool to a testnet, and it's looking like it's going well so far. Right here, as you can see, we have the broadcast deploy community pool. So we know that our community pool is actually being created. The agent is telling us that it's setting up one EVM. This is the estimated gas price to Gwei, and then the estimated total gas used for the entire script. And this is the estimated amount required in Ethereum. And so when our users are using this app, they will press deploy a community pool, and all of these fees will be taken out of their MetaMask wallet when they execute this deployment. So after this agent is done testing to see if it can deploy a community pool to a testnet, a Sepolia testnet, I'm going to manually, inside of the app, do the same thing where I deploy a community pool to the Sepolia testnet. And then we'll go to Sepolia Etherscan and see if our transaction actually ended up on the blockchain. And that is how we know that we have been successful. All right, so our agent is finished, and it said that it was able to deploy this smart contract using an Anvil mock or an Anvil testnet node. And this is the address for the community pool contract. So if you put this address in Sepolia Etherscan, nothing will actually come up because Anvil is just a development node infrastructure. And so Anvil would generate you keys and funds for different crypto addresses, but none of these funds and keys are real. And so we want the agent to deploy now to an actual Sepolia testnet so that we can see this transaction on the blockchain. So the agent is actually telling me that it cannot deploy this community pool to Sepolia from this environment because there's no Sepolia RPC URL in our .env.local environment. And then it also doesn't have a developer private key available for the tool to run. So it would need a real funded account and or its interactive wallet. So I have that in that I have MetaMask in another browser and I have my application in another browser. So I'm going to ask the agent if I am just ready to manually deploy the community pool to the Sepolia testnet using my MetaMask wallet. All right, so our agent says we are good to go to manually deploy this community pool. So I'm going to come over to my application and let's see. Let's click deploy a community pool, and we want to make sure we have the correct MetaMask account. We have both of our accounts connected to our account. That's what the green active bubble means. So we are in the account 1. And as you can see in the background, when I switch accounts, this address will switch in the application also. All right, so we're in the correct account. Now we're going to go to deploy community pool. We're going to name it test pool and say test pool. We are going to fund it with, let's say we fund it with $1. We don't want additional owners for now, so we're going to make it expire in say 2050, and then we're going to review. So pool name, pool description, the supported assets, how much we're funding and the token that we're funding with, and then pool owners, expiration date. So let's deploy this. All right, so perfect. So it did exactly what we wanted it to do. It opened up our MetaMask wallet and it shows us all of the fees that will actually come about from deploying this smart contract. And then all of this hex data is all of the information regarding our smart contract. And obviously we can't read this as a human, but this is information that blockchain nodes can read to discover and learn about your contract, what are the rules of your contract, who owns your contract, what type of contract it is, and so on. So we'll press confirm, and the app says we are working. So now that the app processed our transaction, we are now getting another transaction request to confirm that we are interacting with this account from our localhost. And this warning is just that this is a localhost and I don't have it on an actual browser. And the amount of Ethereum that we are sending. So let's confirm this. And now our application gives us a review of our pool. So it gives us the contract address, the deploy transaction address, and the fund transaction address. So we should be able to take this contract address and go to Sepolia Etherscan and see this contract on the blockchain. And if we come to Etherscan and paste the contract address, we can see that there's one contract from 42 seconds ago. It is a fund type of contract where you can fund it. We have the transaction hash and we have the amount that is now in our contract. And then we can see all of the transaction fees and gas fees and things like that about our contract. And so this is super cool. So now we know that our application can actually deploy a smart contract to a blockchain, and that smart contract can be funded with a token of the user's choice. So I think this is a great place to stop for session 9 of how I'm building a decentralized application. If you have any questions regarding anything that we went over in session 9, remember to leave your comment in the comment section below. Like, subscribe, support the channel, send to your friends and family, and you're watching another video from Simulacra. I'm Bryson, and I'm out. Bye, everyone.
Welcome to session 10 of how I'm building a decentralized application. I'm Bryson and you're watching Simulacra. This is session 10, the last session. In last session, session 9, we went over using MetaMask Wallet Connect, building and deploying smart contracts for the community pool function of the web app, and testing those smart contracts using Anvil and Foundry. And so in today's session, it's a demo. It's a full demo mode. I'm going through the entire web app. I made a lot of changes to the UI, UX. Really not the user experience, but definitely the interface, making it better, making it not look vibe coded for sure. And so we're going to get into it. Remember to like, subscribe. If you have any questions or comments, comment them down in the comment section below. And let's get into it. All right, so this is the landing page, the new landing page, digital treasuries for every community. I really wanted to make the landing page look pretty sleek and not like many people's landing pages. And I think it looks like a pretty authentic and unique landing page to what I want Community Pool to be. So this is where you can sign in. You can either sign in with Get Started, log in, or deploy a pool. I'm going to go through pricing at the end. So this is just a little graphic of what your retrieved balance will look like when you paste an address into the app and you retrieve the balance. The app is mainly supposed to be for personal use and keeping track of your total amount of saved digital assets you have, but you can also look up other people's, strangers, if you can find public wallets on the internet. You can post in their wallet and get the balance of that wallet. How much do you want to fund? This is what the deploy or fund a community pool section is going to look like. Right now, I have Ethereum, PaxG, and Tether Gold. In the future, I might add more digital assets, but these two stable-coins and Ethereum are what I see being the future of crypto. Actually, Anthony Pompliano had a viral tweet the other day, and he was saying that most of everything in crypto is dead. Like, if you're not doing stablecoins, Bitcoin, or infrastructure, it's probably dead. So I'm probably not going to add more assets to be able to be funded with this app. I like digital gold, and then Ethereum is a great token, especially for contract and smart contract use. It says mobilize this morning. I'm filming this in the morning. It's like 8:55 in the morning. I implemented this to make it change. So I think at 12 p.m. when it hits afternoon, it's going to say mobilize this afternoon and then mobilize tonight. I think that's pretty cool. So a quick 1, 2, 3 of how you get into the application, create your account, add an address, connect a wallet, and then you can deploy community pool. We have near instantaneous global pooling. So that is really the biggest advantage of global crowdfunding using digital currency, is that you don't have to wait on anybody. You can get into my app, create an account, connect your wallet, and put up a fund in 2 minutes. And once you put up that fund, anybody that has access to that fund, including you, can then withdraw your money immediately. You don't have to wait for a bank. You don't have to wait to get approved by GoFundMe or Kickstarter. You don't have to worry about not being bankable because you are in a country that the US government considers hostile. And so anybody in the globe can use Community Pool. We're helping humans, not central banks. These are some of the things that Community Pool allows you to do. I'm not going to go through all of them because it's my landing page. You can go to the landing page later. Sound money on chain. Like I said earlier, we're only doing sound money, really. Bitcoin, digital gold, Ethereum. Most of everything else, token-wise, is pretty dead. I really like Hyperliquid and what I've heard from them in terms of 24/7 on-chain futures trading, perpetual futures trading. But for this app,
and for the goal of this app, which is to promote saving and to promote community treasury growth. I want to use tokens that are very stable. I know that will be here in 10 and 15 years in the future. And unfortunately, I can't use Bitcoin because Bitcoin is not great for smart contracts. So we're using Ethereum, PaxG, and Tether Gold. Build your community globally. Try Community Pool now. So we're going to try Community Pool. We're going to log in, and then we're going to send a verification code to my email, or you can sign in with Google for a very quick and easy sign in. So from my email, we're going to come back to the web app and post in the security code. It's going to verify and log us into the app. Cool. So this is our dashboard. Now we want to connect a wallet. I am already signed in to my MetaMask browser extension, my wallet up here. And as you can see, I have $100 worth of digital gold PaxG ready to use. So come out of here. We're going to go and connect the wallet. It already detects our MetaMask because we are connected with our MetaMask in the extension and we're logged into the MetaMask wallet. So just click MetaMask. It's going to open up a new window asking you to confirm the connect for community pool for account 1 or whichever account you want your connection to be. So we're going to press connect. So that's connecting. It comes back to the app. And as you can see, we have MetaMask, Ethereum, mainnet. So perfect. Now we are ready to deploy a community pool and fund it with digital gold. So we're going to go to pools, deploy a community pool. It says complete your profile to deploy. So I have KYC, know your client rules on this app. And I make sure that all of the users on this app have the proper personal information so that I am protected and my user is protected and my app is protected from unscrupulous characters. So let's update our personal information now. Okay, so I updated the personal information, the know your client rules for the web app. Now we're going to, again, deploy a community pool. We're going to name the pool. We can name it Bryson Test Pool, and we'll use the same for the description. We're going to continue. I'm going to fund with Ethereum. I also have wrapped BTC on here. I probably need to take this out because while I like the concept of wrapped BTC, for a community pool treasury, it could be kind of confusing to people thinking that it's real Bitcoin, and I don't want them to think that it's real Bitcoin. So I might take this out later, but for right now, we have wrapped Bitcoin available. But I want to fund with PaxG since I have PaxG in my MetaMask wallet right here. And say I want to fund $25. So I'm going to continue. I don't want any additional owners for right now. Let's add an expiration date of January 1st, 2050. And then let's review our smart contract. We have our name, the description, we have the supported assets. This is what I'm funding with. PaxG, $25. As you can see, I have $100 worth of PaxG over here. I am the only owner, and then it's expiring on the expiration date that we gave it. So let's deploy. And so MetaMask is actually saying that we don't have enough money in Ethereum to cover the network fee. So we're going to need to buy some Ethereum to cover the fee of deploying this contract. All right, so I think this is the cost of building in public. We ran into a bug when I went to deploy that smart contract. It didn't fund, and it was because of a ABI issue. So basically what happened, as you just previously saw, I deployed the community pool, and then I went to fund it with $25 of PaxG. And
it did not go through, and my web app gave me a error. The error was f.allowance is not a function. So after talking with Claude, we figured out that allowance was a error in that the ERC20 ABI fragment list in the community pool on-chain library was incomplete because I used f.allowance, which is not a function. And this needed to adhere strictly to my... And so this was such a big issue because we needed to adhere, as you can see right here, strictly to Ether's version 6 for contract and missing fragments. And so this is such a big problem with the fragment list is because due to Ether version 6's strict binding, those fragments don't get mounted as methods when you call the library. And so this is the solution that I implemented. It's just a single line of code, and then I ran some regression tests, and now I should be ready to fund this contract. So I think this is going to be a good page to use actually. It's called Community Pool Bugs. I think it's going to be a good page. Back in my web app, let's fund one of these contracts. And I ended up deploying 2 accidentally. So we'll just fund one with 25. All right, so our MetaMask opened up. We're actually getting a deceptive request warning because we deployed this smart contract before and we had that bug that go through. So MetaMask is just making sure that this is an actual contract you want to fund and send your money to. It is. This contract is the same as the one on my app and the same as the one in Etherscan. So that is okay. So request from community pool on the Ethereum network, and this is the network fee, and it'll take about 12 seconds. So let's confirm, and now we have our transaction was submitted. In our app, we should confirm inside of our app, and then the amount on the app will change to $25 for PaxG. Damn, another bug. Okay, so we encountered another bug. Let's go investigate. All right, like I said, building in public is you're going to get bugs. You're going to get bugs in public. So that's unfortunate. But it's a good thing that we are doing these tests and figuring out what is working and what is not working in the app. So it looks like we had a boundary rounding bug. Basically, my conversions, transactions, TypeScript file did not have a buffer protecting the flow operations from losing at least one way. And so that's why we had a boundary rounding bug. So this is the fix that we ship to GitHub. This guarantees that the chain side conversion is always above the requested dollar amount. And then we ran some tests, some regression tests, and we passed them all. And so now, finally, we are going to test if we can fund this transaction with PaxG on the mainnet. So we're back on the pools page. Let me bring myself over to the left-hand side. And we're going to press fund. We are still in MetaMask. We are connected. We have our MetaMask open over here. We're going to fund with PaxG for $25. We're going to continue. Review your fund. Cool. Confirm in our wallet. Over here, we have a warning again from MetaMask. As this community pool app grows and has more users, then I'm sure that this warning will disappear. Coinbase doesn't have a warning, Cash App doesn't have a warning, but it's because this is a app with one user on it, it's going to have a warning. So that is the spender, that is our contract, that's correct. PaxG requesting from our app community pool, and then a network fee is going to be 27 cents worth of Ether. So let's confirm.
And MetaMask says our transaction was submitted. And then in our web app is working. And let's see what happens. All right. So MetaMask worked. It says transaction request. You send minus PaxG on the Ethereum network. And so we have a network fee of 65 cents worth of Ether. And so the first approval was due to the ERC20 protocol. Essentially, standard ERC20 funding is always 2 transactions. For the first time, you approve and fund, and there's no way for one signed transaction to both authenticate and spend and execute the transfer. And so it says right here, EIP 2612 permit collapses this into one transaction if the token implements it. PaxG does not. And so for this first fund, I'm going to have to do 2 approvals, and then all subsequent funds, I have made sure that I have unlimited approvals, just like any other exchange or decentralized app or wallet. So let's confirm this next approval. Our transaction was submitted. $25 of PaxG. We can go back home. And in our web app, we can see that the Bryson Test Pool Community Pool was funded with 25 USD worth of PaxG. So to test that, let's go to the Etherscan Block Explorer. And as we can see, we have $25 worth of PaxG on this contract. And as you can see in our MetaMask wallet, the amount of PaxG that we have has decreased. And so now for the final act, let's make sure that we can actually withdraw the tokens that we have put up in a smart contract. So we're going to go here. We're going to press withdraw. Since we only have this ERC20 token in this community pool, we can just say ERC20. We'll say PaxG. And right here, it says we have this amount of PaxG to be able to withdraw. So we're going to max it out, the pool balance. We're going to continue. We're maxing out the pool balance and withdrawing PaxG only, since that's what's only in our community pool smart contract. So let's withdraw. In our MetaMask, we are receiving back that $25 that we have. It looks like it appreciated a little bit in the 30 seconds. So we're going to have to pay a network fee again. Remember, all this requires money through network fees or gas fees. And that is really what makes digital assets, in my opinion, actually way above fiat, is because there are really no transaction costs to using fiat. The transaction cost that your bank charges you to send money around or take out money of an ATM of a bank that's not your home bank, it's all made up. That's just the bank literally stealing money from you. They can just move the zeros around on the computer because they don't actually send money to each other. All of that money is settled at the end of the day through the Federal Reserve. And so that's why cryptocurrency, and especially Bitcoin, requires a way more mature and, quite frankly, responsible patron of that own person's energy and time in the form of money. So let's confirm. Cool. Transaction was received. Let's go back home. And in our web app, we can see that the amount of PaxG is now 0 USD. And we can see
PaxG went up to $99 back in our wallet. So now let's go to the Etherscan. And as we can see, we do not have any more PaxG in this smart contract on the Ethereum blockchain. So this is great. Okay, so this has been a crazy journey. I am really proud of myself for putting myself out there, building in public, building something that I thought would be really cool. And next, I'm on to the next project. The next project will be announced very soon. Very soon, I will start the work on that project tomorrow. And I'm sure in a few days to a week, I will start building in public for that project. So I appreciate everyone on this journey. This has been absolutely fire. Community pool is out. Digital treasuries for every community. Join, log on, fund your community, fund outings, fund anything you want, but fund it with tokens that you can take sovereignty over, tokens that are actually yours. Fund it with not fiat. Fiat is really the death and destruction of our society over the last 100 years. And so let's bring about more of a transparent monetary environment. Digital treasuries for every community. Community pool. Remember to like, subscribe, share with your friends. Comment in the comment section down below if you have any questions or comments regarding this entire series. And remember, on the community pool landing page right here, I have a provide your feedback box where you can provide your feedback fully in paragraph form. I didn't want it to be a choice A, B, or C, or a list or anything like that. I wanted free form conversation. So leave your feedback about this series. Leave your feedback on anything I could improve with Community Pool. And I appreciate all of you. And with that, you've been watching more Simulacra, and I'm out. Bye, everyone.